We begin with the first question in the electronic part. It is to find the critical points of a given function from the lesson 4.3 example 10. It is a simple problem, and since it's an electronic part, we can use our calculators to directly find the answers. You can see there is a fraction, there is a numerator and a denominator. This is a rational function. So how can we find the critical numbers is basically deriving this function and making it equal to 0 and finding the x values. Now, instead of all that, since they have just asked the critical numbers, your options A, B, C will be something like this. Your critical numbers are 0, 4, or they might give you 2, 0, or something like that. How would you know which is the exact critical numbers? Now we can use calculator, directly derive it using the shift and dy by dx over here. When you press shift and dy by dx, this integral symbol, you can derive at any particular point. Now we know the critical numbers in the options. So let me write this equation, 2x squared divided by x plus 2. And imagine I'll take a non-critical number. Let me take 1, which is not a critical number at all. There is some sort of answer. But we know critical numbers are the numbers when the derivative is made equal to 0. The first derivative is made equal to 0, isn't it? So let's see, the derivative over here, critical number is 0. When we derive this given question and we put this critical number as the x value, we must get 0. And yes, we are getting 0. How about minus 4? So just change this to minus 4. And are we getting? Yes, we are getting 0. What about minus 2? Because here the final answer, the critical numbers are only 0 and minus 4. But what if the option is given as minus 2? What will it tell us? Here it will tell math error. Why? Because it's undefined over there. It cannot be possible to have minus 2 as a critical number. So any other values, say for example, minus 3, you'll get some value. So it's not a critical number. Critical numbers are the numbers wherever the first derivative is made equal to 0, and those are the x values we solve. So when we derive over here that critical numbers, your answer must be 0. So say for example, minus 4, 0. So any question given to you, use this shift dy by dx, put in the equation and put in all the 4 options. You will have 0 and 4. Try it out in the x over here. If both are giving you 0 as the answer, then that is the critical number. If only one gives you 0 and another gives you something else, if it was 0 and minus say 5, then we'll get some value over here for minus 5. So that is not the correct answer. Go to the next option and check that, and that's how you can easily solve this using calculator. The second question is about absolute extrema. It is from lesson 4.3. Here in these questions, what we need to do is we need to find the maximum, minimum points. Now, where do we find maximum and minimum? We know it will be either 0, 2 or the critical numbers. Now, since the critical numbers will not be given in the options, we just can't use calculator and find critical numbers. So it is important for us to derive it. There is a calculator method to find absolute extrema, which I'll tell you in a minute. But the actual way would be deriving this given function. Let's get this down over here, the power rule. 3x squared minus 3x power 1 becomes 1. And this is 0. Now then, what else? We need to equate this to 0, make it equal to 0 and solve the critical numbers. The critical numbers can be solved over here because it's quadratic in calculator. All you need to do is mod phi, and then that is equation. If you go back to mod, see where this option phi is equation. It's a quadratic equation, and that's option number 3 because only option 3 has power 2. Now here, before going into the equation, you can see it's x squared. A is the coefficient of x squared, that is number 3. What is bx? Is there any x term? No, there is no x term. So b value is 0 and lastly c is the constant term. So here we need to type 3. There is no x term, so it's 0 and lastly we have minus 3. So the critical numbers are 1 and minus 1. So x, here the critical number is 1 plus or minus 1. So okay, that's plus or minus 1. Now then, Here we have the endpoints, we have the intervals. So the maximum or minimum point can be over here within these two and the critical number, but it's from 0 to 2. So can it be plus and minus? No, it can only be plus 1. The critical number x can only be plus 1. So here we need to substitute these values, all these three values, in the given equation, in the given function, not the derived function, the f of x function, and see which is the maximum and minimum. Now what I'll do is I'll type this given function, x to the power 3 minus 3x plus 1, and calculate this at 0. What is the answer? It's 1. Calculate it at... Now you don't need to write it. If it was writing exam, you have to write it all and then check it over here. But since it's electronic, I'll just keep it in mind. Calculating at 0, it was 1. Calculated at 2. Okay, this is maximum, I guess. Let's see. Calculated at 1. Yeah, the minimum is 1. So minimum would be at f of 1. That is the critical number. We get minus 1. And the max is at f of 2. This over here endpoint. We got 3. So these are the answers. Absolute minimum is minus 1. See, absolute minimum, f of 1, that's the function of at x is equal to 1, it's minus 1, whereas maximum is at 3. And this one is not considered. Why? Because it's in between. Now then, what is the other method? You can do the same thing here, but before going over there, let us go to mode. You can see the table, right? The table gives you the graphs, the x and y values of any equation. So let us press mode 7 and type this equation. X power 3 minus 3x plus 1. And now what I'm going to do is press equal to. You may not get this option. Even if you get this, just press equal to. This is a second equation. No, we just need 1. And where do you start? What are the intervals? It's 0 and 2. Here the step. Most of the time step will work as 1. But if you want more values, you can take 0.1, 0.5. But I'm just going to take 1 and see here. Because you have options, right? You have 4 options. So you don't need to go in more detail. Now let's see. At 0, is it 1? Yes. But the absolute maximum and minimum are these. Is it true? Yes. So from here, you can easily deduce which is maximum and minimum. And easily you can look into the 4 options and eliminate the wrong ones and choose the correct answer. Let's look and try at the question number B. Same thing. Let's press AC. The equation remains the same. But start at minus 3. The lower value, end at 2. So let me just... okay, what is the mistake here? X cubed. Everything is all right. Let's press equal to. This is also equal to. Start at minus 3 and end it at 2. And step let it be 1. And we can see which is the maximum and minimum. Minimum is negative 17. And the maximum is at the endpoint 2. You can see here the minimum value is minus 3. X value of minus 3, that was minus 17. And maximum... Okay, over here you can see it's minus 1. My bad. Now here there are 2 maximums. Minus 1 and you can see over here at minus 1 it is 3 and also at 2 it is 3. So both are maximum values. They peak at the 2 things. And 1, you ignore that critical number. Why? Because it's minus 1. It's just a point in between. Similarly, you can try all these problems in calculators. Since it is an electronic exam, you can use this method. Alpha x to the power 4. Whatever is the given question, type it out over here. And then we have x squared plus 2. And now, press equal to. Let's start at minus 3 itself, end at 1. And you don't even need to find the critical number. Why? Because generally over here, you can easily see which is maximum and minimum and then deduce the critical numbers as well. So you don't need to, solve it, find the critical number and everything. From here itself, from this table, you can see maximum and minimum values, right? And you can easily select the correct answer. Because our main question over here, our goal is to find the absolute extrema. That is, here, what is the maximum and minimum? That is what you're doing. So here you can see the absolute minimum in this interval is at -2. Is it true? Yes, at -2, right? Because it's 11, then -14. This is absolute minimum. And you can see all the other values are not less than or matching -14. What about the maximum value? Is it 11? Let's just look at the values. Yes, it's 11. So maximum is -3 at 11. And these are the critical numbers, but the critical numbers are in between points. So the absolute minimum over here is at -2, that's -14, and maximum is -3. Just using this graph, you can easily find this out. Similarly, for the next one as well, all you need to change is the interval. So we start at -1 and end at 3. And here we go. These are the values. So you can see minimum is at 2x value of 2 -14 and maximum is 311. That's the correct answers. You can try this one as well. Let me just go through this. Alpha x to the power 2 divided by 3. Let's use the fraction symbol, 2 by 3, and then the limits, the intervals are -4 to -2. And here is the values. So in such cases, let's look into the options first. We will look at the options. Okay, we cannot see anything. This over here. The absolute maximum is over here -4. Okay, and absolute minimum is given at -2. Now, sometimes you might have decimal points, but you can easily get it in your options. Your options will have -3.5. In such cases, what would you do? We did not get any case like that as of now. When we come across that, I'll just tell you what you need to do. But for now, you can just compare these values. 2.5, yes, it's the maximum value. And what about the minimum value? It is at -2, that is 1.58. Now, in your answer, you will have such things. So what can you do? You need to go back to computation mode and let's type the shift. And this symbol gives you cube root 16. The value is 2.51. But if it is any other radical number, what you do is just press shift and this symbol here, you can type in any of the cube root value, root value. So if it is 5, you can type 5. But now it's again 3 and then 4. Press equal to, you'll get 1.58. These are the values. But when you do the mode table, more than 7 for table, and then when you solve it up, you won't get in terms of radical, it'll be in terms of decimal. So we can solve the next problem as well. It is 2 divided by 3. Now g of x, ignore that. Started at -1 and ended at 3. Here we are. -1 is 1, 0, 1, and 2 is 1.5, and 3 is 2.08. So which is maximum? It is 3 over the absolute maximum. What is the minimum value? 0 is 0. That is the minimum value. That's it. We do not need the critical number looking at the options. But imagine you get these two correct and then the critical number. You want to check this out. We can do the method which we use in the question number 1. What we need to do is shift and the symbol. Type in the equation x raised to 2 by 3. At the critical number, we must get, this is the critical number, right? We have 0 as the critical number, sorry. It's 0, the critical number. We must get 0. Yes. This is the only answer. Any other value, say -2, you will get some value. So this is not a critical number. So we can easily figure out which is the critical number as well. Only because this is an electronic part, you have the options. Therefore, you can figure out the answers easily here. What happens when we have trigonometric functions? It's not the same. So first, we need to convert to the radian mode, shift mode, and then 4. Now it's in radian. So once the calculator is in radian mode, all you need to do is mode 7 for table and type in the equation. The function is sine x, close the bracket, plus cosine x, over here, close the bracket. And then press equal to, ignore the second equation. Now where do you start? Before I type the values, let's look at these values, 0 and 2 pi. What do they mean, 0 and 2 pi? So 0 is 0 degrees, 2 pi is 360 degrees. What's the midpoint in between them? It's 180 degrees, right? That is pi. What's midpoint between them? It's 90 degrees, and that's pi by 2. The problem is, since sine and cosine, it's not 100% sure you will get some maximum or minimum. You might get maximum or minimum, or it might be at pi by 4, that is 45 degrees. Because these are the important points, right? When we graph, it's 0, 45, 90, 135 here, and then so on. So all you need to remember is whenever you have trigonometric functions, stick to 45 degrees. Almost always 45 degrees will do the trick. Only complicated problems we use 30 degrees, but that's not over here. If you're graphing trigonometric functions, that's a different thing altogether. But now here, 45 degrees is enough. So what do we remember is 45 degrees is the step, but we write it in terms of radians, isn't it? Because we don't want to convert everything in degrees and all that. Because here, generally, most of the time, whatever is given to you is in terms of radian. I'll also do this problem if it is given in degrees for you in the exam. I'll solve it even in degrees. But first, let me solve in radians. So here you remember the step in radians will be pi by 4. So pi by 4 is basically half of 90 degree, that's 45 degrees. So your start will be 0, end will be 2 pi, shift over here, that's pi. What about the step? Step is pi by 4, so it will be, now I'll just write pi first. The fraction symbol will look like that, or you can just put divided by 4, that is also more than enough. And look at these values. Here you will only get in decimal. So it's 0, 0 is 1. 0, what is the 0.78? This is pi by 4. Pi by 4. Because pi is 3.14. When x value will be considered in terms of 3.14 divided by 4. Whereas 1.57 is pi by 2. You can see 3.1415 is pi here. Since the step is given as pi by 4, after 0 will be pi by 4 and so on. You need to just remember this. Now this first value is pi by 4, second value is pi by 2. Because if you just put this in the calculator, 1.5707, you just put pi by 2, you will get the same value. So that's the thing. Now let's see over here, what are the maximum? Maximum is at pi by 4. And what is the minimum? Over here, minimum is after pi value. Pi is 3.14, isn't it? After that comes 1.25 pi, or it is 5 pi by 4. So that should be the maximum and minimum values. Yeah, those are the values. Let's look over here. It's pi by 4 is the maximum. That is root 2. 1.414 is root 2 value. See, it's square root 2. And 5 pi by 4 is minimum over here. That is at 5 pi by 4. 5 pi by 4 means, you can see it's 3.926, right? So that's the thing. If let me just go out and let me show you 5 pi by 4 is equal to 3.92699. That's how we solve this. Now, what if we have in degrees? Then also we can solve this easily. Let me clear the calculator for now, because the default mode is in degrees. You can see it's degrees. You need to type in first mode 7 and type this out. Sine x, close the bracket, plus cosine x, close the bracket. And then let's press equal to ignore the second equation. Start at 0 degrees, ending at 2 pi means it's 360 degrees. Now what is the step? It's 45 degrees, right? Let's put 45 degrees. Here you can see at 0 it is 1, at 45 degrees it is 1.41, 90 degrees and so on. You can see over here. 225 degrees is 5 pi by 4. If you're finding this to be easier in terms of degrees, then please stick with this, but make sure you convert everything to degrees. But if you want to take these values as it is, then you have to take radian mode itself. So that was the answer. Over here we got these. Now what about the next one? It's absolutely the same, mode 7. But here I'm going to convert to radians, shift mode 4. Let me type the given equation, sine x plus cosine x, and close the bracket. And then we have the starting point as pi by 2. So here starting is pi, shift and pi divided by 2, and ending is pi, that is just pi. And step, I'll give it as pi by 4, pi divided by 4. Here we go. We have maximum at pi by 2, that is, and minimum is at pi. We can see here 1, that is maximum, absolute maximum at pi by 2, that is equal to 1. Pi by 2 is 1.57, that's 1. And the minimum value was at pi, the endpoint, that's minus 1. So that's how we solve it. When we have just normal equation other than trigonometry, it's pretty simple. We can clear the calculator now if you want to just get rid of everything. Now we can go to mode 7, shift e to the power minus x squared. And here then, where do we start? Start at 0, end at 2. And let me give the step of 0.5. Let me show you what's the difference. Let's look at the answers. Here also the values are whole numbers itself. But here if you put 0.5, you will get more details. You'll get 0, 0.51, 1.52, and so on. So you can compare which is the maximum here. Maximum as of now it's only 1, and 1 is the maximum that happens at 0. Absolute maximum, x is 0, 1. What is the minimum? You can see minimum is at 2, and that is 0.0183. How do you check this? We need to go to computation mode, shift e to the power minus 4, press equal to, it's 0.0183. So in the options, if this is the answer, you just have to change, go to the computation mode, check it out, and then do it. So what I would suggest you is if you have plenty of options in terms of e to the power 3 or minus 3, something like that, look all the options, solve it up first, and then do the table method, mode 7, and so on. That's how we do it over here as well. Mode 7, it's e to the power minus x squared. So x minus x squared. And where do we calculate? Starting at minus 3 over here and ending at 2. And step, I'll just leave it as 1. And you can see over here, minus 3, it's 1. See, it's such a small number. It's 0.000123 and so on. And that is the minimum. What is the maximum? 1 is the maximum, you can see. So that's how these two are the extremas. Similarly, you can go on trying these problems. You can use the manual method as well, but the calculated method helps you out instead of using product rule and everything. Because here, otherwise it would be product rule, chain rule and everything, right? So that is all avoided. Let's do this again in calculator. You need to press mode 7 and then we need to type this equation in. It's x squared times e to the power minus 4 times x. And now here, press equal to, start at minus 2, end it at 0. And here we go. The maximum value is at 1, minus 1, and minimum value is at 0. So that's the answer. So you can see absolute max is at minus 2. Is it so? Oh, yes. I'm sorry, I thought this was 1 point or something. Look at these values. It's 11,923 at minus 2. Whereas at minus 1, it's just 54 and it's 0 at 0. So absolute minimum is at 0, which is 0. Absolute maximum is at minus 2, which is 4 times e to the power 8, or that is equal to 11,923.831. That's how we solve it. Over here, 0 and 4. You can try the same thing and you will get the answers. All the other problems, also you can do the calculator method itself. Mode 7, type the equation out. It is just typing it in, 3x squared by x minus 3. Now press equal to, don't type anything in g of x. Start the values over here at minus 2, end it at 2. And step of 1. And then look into the options and you can easily figure out the correct answer. Here you can see the critical, they've just used all this, the quotient tool to find the critical numbers, and then you find the maximum and minimum points. So here absolute maximum is f of 0, and that's 0. You can see over here, yes, that's 0 and 0. And the minimum over here at f of 2 is minus 12. Similarly, you can do the next one as well. Okay, this is not continuous. So now what does it mean? Let's go and try this. Mode 7, you can type this out. It's 3x squared by x minus 3. Now, if it is not continuous, there must be some discontinuity, right? So let's try the starting point 2 and ending point 8. Now let the step be 1. Look here, there's an error. Error means there's an asymptote. So of course this is not continuous. Why? Because there cannot be absolute maximum nor minimum. There is no max or minimum. Why? Because asymptote, it goes to infinity, right? Because we get an error in the calculator, we can check it out. So when we get the error, there is no it's not continuous. That's the answer. But generally in your exams, you will have some answer. It'll be maximum, minimum. This answer will be there. So this must be given in your options. Similarly, do try these problems by yourselves. Over here, it's tan inverse, but you can see the limits are 0. The limits or the interval is 0 and 1. So you just have to type this out. Let's use a calculator. Now here, since it's trigonometry, I'll press shift mode 4. Now it's in radians. Let's go to mode 7 for table. Tan inverse is shift and tan. And then you press x squared. And then close the bracket. And here we have the limits 0 to 1. And step is 1. Here, which is minimum and which is maximum? Minimum is 0. As you can see, the absolute minimum is 0. That's 0. And maximum is 1. That is pi by 4 or 0.753. This is equal to pi by 4. What about the next value? So same thing. Let me just press AC. So the same equation is there. And I will start it at minus 3 and I'll end it at 4. And here we go. The answers are it's 1.4. So the maximum is 3 over here 4. Absolute maximum is x value of 4. That is tan inverse 16, or it's given as 1.5083. But the minimum was 0. We got it at 0. So that is the absolute minimum. In your exams, you need to figure out what is the maximum and minimum point. Similarly, try these problems. We have tried similar problems, and here you go. The answers are visible here. So maximum, minimum can be found out. Calculator method is very easy. You don't have to derive anything. You don't have to spend time on that. So here as well. Otherwise, we have to use a quotient rule, which is really hard, isn't it? Find the critical numbers, and then you have to find the maximum and minimum. So when we graph, we directly get the answers. We can know which is maximum and minimum. The third question is to find the local extrema using the first derivative test. It is from the lesson 4.4. Here they have asked us to find a lot of things. First, we need to find the extrema, then increasing, decreasing, and also sketching graph. So let's do each of these part by part. If you have to find the absolute maxima, minima, we have used a direct shortcut method in calculator for the question number 2, the previous one. We can use the same thing. Increasing and decreasing function also can be done by the mode 7 method. And if it is sketching graph, you will have 4 options of graph. Easily you can figure out using calculator and the given equation, which is the correct graph. I won't go into the detailed method since it's the electronic part, but for one problem, I'll just show you how it is done. First, we find the derivative. First derivative, it will be 3x power 2 minus 3. And then what we do over here is we have to find the critical number, making this equal to 0. And I'll take 3 common out, x squared minus 1. So x is equal to plus or minus 1. This is the critical numbers here. From the critical numbers, we can easily find where it's increasing and decreasing. So what we do is we take the critical numbers, minus 1 and positive 1 over here, and choose a test value. So test value is anything less than minus 1, it's minus 2. Anything between 1 and minus 1 is 0, and over here 2. So what you do is you put these test values in the first derivative. This is y dash of x. So here, if you substitute minus 2, it'll be, I'm just going to do in mind quickly, minus 2 square 4 times 3, it'll be a positive value. We're not interested in the exact value. We are just interested whether it's positive or negative. Here it's positive. When you put 0, this is 0, it's negative. And again, when you put 2, it'll be positive. So it's increasing, decreasing, and increasing. That is what they wanted. And over here, we can see this will be the maximum, local maxima and local minima over here at minus positive 1. So you can get this information from this first derivative test and over here. And if you want to graph, you can do again concavity and all that, but there are easier methods to figure out which is the graph. Now in the calculator, what do we get? Here using the mode 7 and typing in the given equation, that is x to the power 3 minus 3x squared plus 2. Sorry, it's just 3x, my bad. Away it's just 3x. And if you put this in the calculator, press equal to, there's no second equation. Let us start, see over here there is no intervals. So let us start at say minus 5 and end at 5. And it would be really nice if we give a step of 0.5. Okay, now it's insufficient memory because there are too many values. So we can, you can maneuver these. I mean, you can manipulate these values from minus 5 to 0 and then so on. But I'll leave this start and end and let me give step of 1. Now you can get the values. Here, what I'm interested is where it's increasing and where it's decreasing. See here, it's decreasing, right? Sorry, it's increasing, right? It's negative numbers. It's becoming bigger and bigger. And it goes to 0. It keeps on increasing. But after minus 1, look at this minus 1. It reaches 4, but then it drops. It's decreasing. So you can follow this as well. It was increasing. It reached minus 1, peaked up over here at the value of 4, and then it's decreased. See at 0, 2, and then it reached until 1, that was 0, but then again 2 is again increased. So you can see it was decreasing until 1, and then it's increased. So you can figure out this increasing, decreasing, wherever the function is increasing and decreasing from the calculator as well. Or you can do the first derivative test and find it. Now, what if the graphs are known? Now, if the graph is given to you, you will have 4 separate graphs and you need to choose the correct graph, isn't it? So you can easily figure out by making this table. Of course, by making the table, you can see if it's at minus 2, what should be the value? It should be 0. Yes. If it's at minus 1, it should be at 4, and that is 4. And at 0, it should be at 2. And you can easily understand the graph. But there's another easy way. You can just put this given equation directly in the calculator in the computation mode. And over here we have minus 3x plus 2. And then choose any x value. See over here, I'll just calculate at minus 2. So what this gives me is, at minus 2 it should be 0. I will look into all the other graphs as well, other options. And if it is not giving a value of 0, it's not touching the x-axis, then that's the wrong graph. And then if there are 2 graphs at the same point, at minus 2 it's 0, then try some other point as well. Let's try 0 over here. Let's calculate at x value of 0. It should be, it's 20, so it should be 4, 8, 12, 16, 20. So half of 4 is 2. Yes, absolutely, it is true. Whereas all the other graphs can be eliminated. So this is how we can easily figure out which is the correct graph. Now here they have clearly asked we have to graph them. So all these problems, what you need to do is you just have to put in the equation plus 2x squared, and then we have plus 1. So put in the equation and look into all the 4 graphs and calculate different x values. So I'll calculate at 0, it must be 1. And you can see that's 1. What about minus 1? It should be around 2. So calculate at minus 1. It's, yes, 2. What about minus 1.5? Calculate at minus 1.5. It is 2.21. Is it true? Minus 1.5. Yeah, it's approximately true. So this is how we can easily eliminate the other options. Within 2 or 3 values, you'll definitely get the correct graph. Whereas we know how to find the increasing and decreasing just by mode 7, which we have done thoroughly in the question 2. So please go back to the question 2 if you want to know how to find the increasing and decreasing. It's just by mode 7 and table. Now here as well, we can just look into the graph and we can look into the equation, type out this equation. It is alpha x to the power 4 minus 8x squared. Even over here you can do the table, but this is easier because you will have 4 graphs. You know, say minus 2 is different for all the graphs, so I'll just choose calculate at minus 2, and over here we are getting negative 15. All the other graphs are different, so you can easily eliminate that other graphs and choose this as the correct answer. So that's the thing, and all these problems are just similar. You can go through them by yourselves. Whenever you are to find graphs, it's very simple and easy. Now this one as well, it's just that choose some points. Now whenever you see to the power 2/3, you can understand there's a cusp over here, sharp edge. Whereas also looking at the other graphs, this is a cubic graph. Yes, this is a cubic graph. Let's see some others. Over here it's 1/3. So over here this is like this shaped. Whereas if it's sine and cosine, it should be something like this, like waves, isn't it? So you can figure out from the options as well which is more likely the correct graph. But if there are similar graphs like this, then you need to use your calculator and get the accurate one. Sine squared is just going to be long amplitudes, and here it's exponential. So since it's x squared, then parabola is also there, and then it's exponential as well. And lastly, natural logarithm. Over here, this is undefined at 0, so it'll go close, and asymptote is at 0, so this would be the answer. So this is how we can easily figure out the correct graphs. Just use your calculator and you can get the correct graphs. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. Question 4 is about increasing and decreasing functions from lesson 4.4. This is very similar to the question 3. The same method can be used to solve these problems. And here they have also told to find the asymptotes and extrema, which we did last problem, and also sketching graph. So asymptotes can be found out by taking limits and finding where exactly they are. Now over here, basically the denominator, when you make it equal to 0, you get the undefined values. Those are the vertical asymptotes. So the horizontal asymptote can be found out by taking the limits until x is going to infinity. You will understand where the horizontal asymptotes are. Here we can just use the calculator method because it's electronic part again. We can just stick to mode 7, the table, and type this equation out over here. It's x by x squared minus 1. And now g of x is not there. Start it at, say now here there is no intervals given. So it's better to start it at, say, minus 5 and end it off at 5. And the step that will be 1. And you get the values over here. So here you can see there is some errors. What does those errors mean? Those errors are the undefined values. Over here, x squared minus 1. That means plus or minus 1 are undefined. The domain doesn't exist over there. So those are the asymptotes at minus 1 and positive 1. Now here you can see the function is decreasing before minus 1. And yes, in the graph also it's decreasing. So if you wanted to write the increasing and decreasing intervals, then from here also we can directly tell it. And then after the, say over here, then it's 0. See, now if you take 0.5 or other steps, then you can understand what's happening here as well. But overall, you can find the other values. After 1, what is happening after 1? It is decreasing. Can you see it's decreasing? The values are decreasing. So if you wanted these values, just take 0.5 step, you'll get over here as well. So here was decreasing as well. So this is the thing, but the best and the easiest way to figure out what is the correct graph, as we did before, is just type the given question in the calculator directly. It's x squared minus 1, and now calculate it at different values. At 0 it should be 0, yes it is. So what about say 0.5? Let's calculate it at 0.5, and it is 0.667. So negative at 0.5, it's somewhere over here. Yes, it corresponds. It's not exactly minus 1, but less than that. And what about negative 1 or positive 1? It's math error, and even for negative 1 it will be math error, because those are the asymptotes. So similarly, you can choose any other points and figure out which is the correct graph. And here as well, you will have 4 graphs. All you need to do is select the correct one. Over here, the denominator, you can see, is x squared minus 1. So when you make this denominator equal to 0, you will get over here, that is plus or minus 1. So those are the vertical asymptotes, and horizontal asymptote is also there since they are same degrees. So 1 divided by 1, it's at y is equal to 1. So those are the asymptotes, and that's how we graph this. Here as well, the main emphasis is given on graphing. Once you derive it, you can easily graph it up. Now, when you put this equation in the calculator, and you can check any value for that matter, the asymptotes will be error, all the others will give you the answer corresponding to the correct graph. Now you can quickly put this in the calculator and even find the asymptotes in the calculator. Now, what if your scale is not accurate enough? You can manipulate the scale. Usually, if you take a step of 1, that's more than enough. That should give you the correct values. But if you take 0.5, then you'll get a lot of values. So here we have square root in the denominator only, and when you graph it, it's going to be like this. Such graphs are very easy because you will have 4 graphs and just calculate it with this equation, check out the correct graph. This one, let's do this one. All you need to do is put it out in the calculator. X squared plus 2 divided by, open the brackets, x plus 1. And the denominator is only squared. So let's look into the 4 graphs. We should have the 4 graphs and then calculate it at, say, 0. Is it 2? Yes, it's 2. Let's calculate it at 1. Is it 3/4 at 1? Somewhere over here. Yes, it's a 3/4. And then calculate it at 2. 2/3, 0.66. See at 2. Yes, it's decreased from here, right? 0.5 is over here. It's way above compared to what is that at 2. And you can try even the left side, say calculated at -2. And that'll be 6 here, -2. Yes, that's correct. So that is how we can easily figure out the correct graph. For the increasing, decreasing, we can go to mode 7. We have done it already plenty times before. From mode 7, you can easily put this equation, and from the calculator, you can easily understand how it is behaving, whether it's increasing or decreasing. Question 5 is to find the local extrema using first derivative test from the lesson 4.4. This is same as the question 3. So I would highly recommend you to go back to the question 3, watch that video properly, and then come back over here. I will solve one problem thoroughly in detail, and all the others I'll just solve in the calculator. Now what we do is over here we need to find the first derivative to find the critical numbers. Over here when we derive this, it's going to be 4x power 3 plus 3 times 4 is 12, x squared minus 0 because the number is gone. So this is gone basically. Now here we have a cubic function. We need to find the critical number. So make this equal to 0, and then we have 4x cubed plus 12x squared. You can solve it manually here by taking x squared outside, or I'll just show you the calculator method to find the roots. All you need to do is mode, and then you need to press 5 for equations, and here we go. That's cube. This is quadratic and this is cubic. That's option 4. Now type in the coefficients. If you go to mode 5, you can see x cubed. Before x cubed is a. What is before x cubed? That's 4. What is before x squared? That's 12. What is before x? There is nothing, so it's 0 and this is 0. You can't put 1 because it's plus, so only 0 will work. If there's nothing, it's 0. So let's press 4 and type in the coefficients. 4, then we have 12, and then we have 0 and 0. And the x value, the critical numbers is -3 and 0. So let's write these out over here. The critical numbers, x is equal to -3 and 0. Now, if we draw a straight line over here at -3 and at 0, we will have some depth, we can have a maximum or minimum point. Now, what we need to do is, in order to find increasing and decreasing functions, we choose a test value. From here, we choose a test value, and put it in the derived equation. That's over here, this one. So I'll choose -4 less than -3. Over here, I'm going to choose values of -1 and 1. Then I'm going to substitute it in this equation, the derived equation. We can use the calculator here. In order to go out of this, AC doesn't work, on doesn't work. You need to just press mode and 1, that is back to the computation mode. And then I'll type 4x cubed, that's alpha x to the power 3, not minus, 12x squared. Here, calculate this at these test values of -4, it's negative. And let me calculate at -1 as well. -1, it's positive. And lastly at 1, it's positive. So calculated 1, yes. So I got minus here, plus, plus. So what's happening is, over here it's decreasing. This is reducing, then it's going up and up. So this is the situation of this graph. You can see there's a dip, but then it just keeps on going up. How would you find the maximum and minimum points? Here there is no interval, so we have to just find these 2 points. Let's put them in this given equation, -3 in this given equation, not in the derived one, because if you find the derived one, it's 0 over there. We need to use the given equation. Just type this out in the calculator and then calculate the values at -3 and 0. Here we have to put x power 4, that is alpha x to the power 4, plus 4x cubed, that's power 3, minus 2. And here we go, that's positive 3 over here. Oh, sorry, this is not the correct answer. I need to calculate it at what? -3. So the minimum value is -29. At this point, the graph would have -29 over here. And what about 0? Calculated at 0, it is -2, but that is not the maximum point. Why? Over here, I don't even need to write, because you can see the graph is dipping down and then it's increasing and increasing. So there is no local maximum. There is only local minimum over here at -3. So the answer would be local minimum at -3. So you can see here, x is equal to -3 is a local minimum, and x0 is not an extremum. Why? Because it is not having something like this. If this would have been going down, then it would have local minimum and maximum, right? And then the graph continues. But you can see this is x to the power 4. It is a parabolic sort of thing. Here we got a minimum, but no maximum here. So how can we figure this out in the calculator? We just have to graph this out. So let me take the calculator again and use mode 7. Here, mode 7 gives us, and this given equation, we don't derive or anything. So this is the best part in the calculator method. You just take the given equation, type it out, x to the power 4 plus 4x cubed, and then we have -2. And once we type this out, ignore this. Most of the time you won't even have this option. You'll directly have start. Start at a reasonable value of -5 and end at 5 and step of 1. Now look at these x values. Here you can see it's very high, positive 123, and it's coming down, down, and you can see the minimum most point is -29. Then what is happening? It's increasing, increasing, increasing. It's just increasing. So even from this, you can easily understand it was reducing. It reached the minimum point, that's -29, and then it just increases. There's no more dips. So there is only this is correct. Local minimum at x is equal to -3. The value was 29 of that. So since this is the electronic part, you can use your calculator. If you want only the critical numbers, if the options are to find critical numbers, then we have seen in question 1 how can you do it directly by the derivatives at these values. Then if you want increasing and decreasing, you can just use mode 7. That is in question 2, much in detail. You can watch question 2 again. So the same methods, what we have done in question 2, 3, 4, will continue over here. Let's do this problem directly in the calculator. So again, you can press AC and write it out. You can clear it off, or you can just go to mode 7. Now we have x power 5, then minus 5x squared plus 1. Here you just press equal to, and we will start at a reasonable value of -5 and end it at 5. And step of 1. Now let's see what's happening. Here it's reducing, decreasing, sorry, it's increasing. It's negative numbers, right? So it's increasing, increasing. It increased. It reached a peak at around 0, and then it's again decreasing, and then it increased again, and it's just increasing. So we can see there are local minimum and maximum. This is the maximum. Let's check whether it was 0 maximum. Yes, we got the maximum, right? And then it dipped down again, and then it goes up. See, if you graph it out, if you had seen the points, then it was going something like this, and then down and then up, right? So this is what we had seen. So this much over here, local maximum, minimum. Local maximum was at 0, and what is that? What is the minimum point? It's exactly at square root cube root 2. Now we can look at this. It was increasing. The values were increasing, 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 and at 0 it reached the max, and then it fell down, right? But then again it increased, because root 2 is somewhere in between, less than 2, isn't it? Sorry, cube root. So what you can do is you can just put this shift, and over here shift, and this symbol or this symbol. This, you can just type out the cube root by yourself. You can choose any cube over here, and the answer is 1.2599. Now how would you know exactly in the calculator, because the table doesn't give you this value exactly, right? So you look into the 4 options. Of course, at least 1 point you will get a reasonable answer from here, from the table. You can easily understand where it is increasing, decreasing. We got this right from the table here, and then just use the computation mode, solve these terms exactly, and then I can tell yes for sure, because after 1 and below 2 it was dipping down. It had its minimum point. Of course, this must be the correct answer. There can't be any other correct answer. And you can easily figure out the approximate answers and then deduce which is the correct answer, because you'll have 4 options. All cannot be at the same points. In the other option, it might have been x is equal to 0 as the local minimum, and this will be at maximum. So you can easily figure out which is the correct answer. That's how we can solve it. Even this over here, we just go to mode 7, and then x multiplied by e to the power -2 times x. And then let's start at say -5 and end at 5, and the step is 1. Now here you can see the values of y. It's huge value, it's small values because it's minus, right? And it's increasing, it's keep on increasing. And now anywhere over here it can fall down. Now because our values are not, our steps are 1, it can be anywhere over here. So this, somewhere over here, it has fallen down. Why? Because you can see the values were increasing, increasing. Till 0 it was increasing. It reached 0, then it just went up and then down. So it can be anywhere from x is equal to 0 until 2. I can tell somewhere in between over here we have a maximum point. It's only a maximum point. And then where is the minimum point? There's no minimum point because it's becoming flat. It's like an asymptote towards 0. So if you're graphing a little bit more accurately, the values were very steep and then it went up and something like this. There is a maximum point. It's in between 0 and 2. Let's look into the options. You'll understand that's the answer. The local maximum is at half. Yes, reasonably right. It's just before 1 and then it was dipping down. So that's true. Now, if you want more detail in the graph, Since you will have four options, you know there is half, 2, 1, then what you can do is, let's go back to that. In the step, in the starting point, instead of -5, I'm going to just use -2. And I'll end it at, say, 2, because I know after 2 it is just a flat line. And then over here, I'm going to use a step of 0.5. Now you can see there's more details here. It's increasing here, increased to 0 and increased. But then over here, this is the maximum point, and then it's dipping down, isn't it? So 0.5, yes, it's accurate enough. That is the correct answer. So looking at the four options, you can easily manipulate the table and then get the correct answer. Similarly, please do try these problems by yourselves. It's just mode 7. We have done plenty of problems already. Here, the answers are already there. See, in this question 5, your options might be where exactly is the slope changing. So you might have x is equal to 0 is the local minimum, x is equal to is local maximum. That is one correct answer. And you might have wrong options. They might give you, say, x is equal to 0 is local minimum, x is equal to -2 is local maximum. No, that is incorrect. So you need to look carefully. In the table, mode 7, you get all the values. So compare which is the correct answer and eliminate the wrong answers. That's how we can easily solve it in calculator. Even over here, we have done this similar problem before, I believe. So we have to type this out. Make sure you convert this degree to radian because we're using trigonometry, isn't it? Shift, mode, and 4. And then it'll go to mode 7 for table. It's tan inverse x squared. Let us look into the options. Where is the x? It's around 0. So what I'll do is, we can easily find this options, right? X is 0 is a minimum point, -2 or -1 or 2, 3. So what I'll do is, looking at the options, I will manipulate my starting point. I'll give it, say, -2 and end it at 3, and I'll give a step of 0.5. Here now we can see it is 1.3. It is reducing. 0.78, it's decreasing. It reached 0 and then, okay, you can see it's touched 0 and then it's increasing. So it dipped down and then it increased. So what happens? It's keep on increasing now. That means it has a local minimum. Yes, at x is equal to 0. This is correct. Similarly, this one as well. Here, now let's try this one in calculator. Mode 7, sine inverse of 1 minus 1 divided by x squared. Close the bracket. And let's say start at -3, end it at 2. I'll take a step of 0.5. What is happening here exactly? You're getting error. What does this mean if you're having error? That means this cannot have, this is undefined. This is not continuous, right? The derivative is never 0. It's not defined basically. So there are no critical points. There cannot be local maximum and minimum for this. We had a similar problem before as well. Similarly, please do try these other problems. Just put in the calculator and you can look into the options and then check which is the correct answer. So here as well, here there are local minimum maximum. And even if it is not a whole number, doesn't matter. You just have to manipulate the step value. Put a step of 0.5 and then looking at the answer, you can easily figure out which is the correct answer. So that's over here. Please do try them by yourselves. You don't need to solve anything. You don't need to derive anything in the calculator method. Just putting this in the calculator, looking at the given values and looking at all the options, and then deciding which is the correct answer. In this question, we will find the inflection point. It is from the lesson 4.5. We have been given an equation and we have to find the concavity. Now, one problem I will do it properly using the concavity and everything. Other problems I'll directly tell you how to find the inflection point. Sadly, there is no calculator method for this because we have to double derive this given equation. What do we do is, as you see this equation, you need to derive it once, and that will be 3x power 2 minus 6x power 1 because it's 2 minus 1 and then plus 4. We have done this derivations plenty of times. Now it's not over. One derivation, we can do it in various ways, shortcuts and everything, but you cannot do double derivations in the calculator. So you have to do it manually. It'll be 6x minus 6. That is dissolved. This is gone. Now what you need to do is the second derivative, the double derivative of the given function must be equated to 0 and solve for x. So I'll directly put this 0 and we have to solve. Because it's not power 2, it's better to solve it directly. You can use a calculator as well. You can put the 0 equals 6x minus 6. But if it's quadratic or higher, calculator is necessary. But if it's only power 1, then directly you can solve this. Take the 6 to the other side and divide both the sides by 6. It'll be 1 is equal to 6. So the inflection point is 1. Most probably this will be asked for exam. You will have 4 options of x. So x1 is your correct answer. But if you want to know the concavity, imagine this is the graph. X is equal to 1. Let me take it over here. Here it's until infinity, minus infinity. And let us take a test point less than 1. I'll take it as 0, and more than 1, I'll take it as 2. The double derivative, this equation must be used in the calculator and check what is happening. Here I'll just type this double derivative equation, that's 6x minus 6. I'll just show you if you're wondering how to solve this in calculator. You just press equal to 0 and not equal to, you should press shift and solve. And then if you press equal to, the answer is 1. But now that is not what we are solving for. We are using this equation and testing it at 0. Calculate it at 0. What is the value? It's negative. What about positive value? If you calculate it at 2, here it's positive. So it's minus here and plus here. That means it's concaving downwards and upwards over here. So this is the concavity at the inflection point. So you can write x greater than 1 will be concaving upwards. Concave up, and otherwise it's concave down. Let's look at the answer, how they have written. You can see x1, that is the inflection point. That's the most important thing. Now, f double derivative is greater than 0 means it's concaving up from greater than 1. That is 1 to infinity. X is greater than 1. That is 1 to infinity. It's concave up. Why? Because the double derivative of x is greater than 0. Whereas when it's less than, over here it was negative, right? It's concaving down from minus infinity till 1. That is how we solve it. But here mainly focus on the inflection point. I will try for solving all the other problems only at the inflection point directly. Whereas the concaving, you can just draw a small graph and check it out. Here what's happening? It's the same type. First derive once. That will be 4x power 3 minus, it is not 6, it will be 12 x plus 2. And double derive it. It is 12x power 2 minus 12. That's it. Now, since it's power 2, I will use a calculator using mode phi 3. Quadratics, this is a quadratic, power 2, right? Just click on mode, and in equations, if you go phi, the third option is quadratic equations. What is before x squared? It's 12. But you can see there's no x term. Don't write it's minus 12 here. No, it's 0 because there is no x term here. Then minus 12. Here we go. The answer is 1 and minus 1. So there are two inflection points. X is equal to 1. X is equal to minus 1 or plus or minus 1. You can write this. Anything can be your option, you know. Now, if you have to do the number line over here, remember there'll be minus 1, there'll be plus 1, and then there'll be 3 intervals. Then you can find which is concaving up and down. You can see over here the answer is given as minus 1 plus 1. Here as well, we will quickly derive this problem. Now, how can we derive this? F of x will be equal to x, let it be, plus, I'll take this 1 by x, right? Upside, this x goes up, it'll be x minus 1. Now let me derive it over here. It's going to be 1 plus this minus 1 comes down, and x minus 1 minus 1. What happens? This is the first derivative. The first derivative will be 1 minus 1 is just minus, right? Because minus 1 means minus x minus 2. This is the thing. But we want double derivative. So when we double derive, this number is gone. It will be 0 minus minus 2 times x. Now I do not need to put this bracket over here, because minus 2, because there was a negative sign, I put bracket. It's minus 2 minus 1. So what is happening here? It'll be 0 minus plus 2x minus 3. Now then, this is a single term. 0, I'll just remove it out over here. This is the double derivative, right? Now make this equal to 0. So f double derivative is 0 is equal to 2x power minus 3. What is the answer? X is 0, right? Because right side is 0. This variable has to be 0 because this is a number. However, it doesn't matter what. You divide both the sides by 2. You take the cube root or anything. X will be 0 is the inflection point. Now here there's one important thing to remember. Whenever you have fractions like this, say imagine you have x power minus 3 and here you have anything, it should be either x or number. If you have x, or say like this plus 2, imagine this is your equation. When you double derive, this is going to be 1 and then a number, constant 0. This will be 0 at the first derivation only. So you're only remaining with this. You'll remain with x minus power 5. Then you're making it equal to 0. So no matter what, your inflection point will be 0 even for this problem. Directly you can tell. Because this is not there, only a single term. When it's equal to 0, it will be 0. The variable will be 0. So the answer is 0 here. What about this one? Now here, I can tell this is going to be 0, right? It's gone when you double derive. These numbers and all can be gone, but whatever is inside, right, will be x is equal to 1. Directly you can tell this. So x will be equal to 1. Let me just check, because it's minus x. 1 minus x is equal to 0. Minus x to the other side will be x is equal to 1. See, this is the point of inflection, but let's solve it. What happens over here? When you first derive it, it's going to be 1 plus. Now here, 3 is a coefficient number. That is fine. But this is the power rule. So it'll be multiplied by 1/3. This power comes down. And then we have 1 minus x, the whole power, 1/3 minus 1. And then we have to solve this up. We have to multiply it with what? You have to multiply it with the chain rule. Whatever is inside, when we derive whatever is inside, it's just going to be minus 1. Because 1 will be 0, minus x will be minus 1. This is the power rule, this much. This is the chain rule. Whatever is inside, we also derive it. So first we derive the power and then we come inside. So if it was only x, it would just be 1, so we don't write it, but it's minus x, therefore we write it out. Now the first derivative is equal to 1 plus this 3 and 3 cancels off. I should have removed the plus. Why? Because it's going to be minus, right? There's minus 1 here. So it's going to be minus 1 minus x. What is 1/3 minus 1? It will be negative 2/3. You can just use your calculator for that. This is the first derivative. Now let's do the second derivative. When we do the second derivative, it's going to be 0 minus, and we'll have minus 2/3. 1, let me just remove that. 1 minus x. Now minus 2/3 minus 1. Here it'll be minus and minus is plus. So I'm just not going to write the sign. It's positive. 2/3 times 1 minus x. Okay, I forgot to write one important thing. After this, there is again the chain rule, minus 1. Don't forget that. So there's 3 minus. Minus and minus will become plus, and there is 1 minus remaining. So I will leave the negative sign. Okay, this is very important. It's minus 2/3, 1 minus. I mean, if it would have been very important if it's writing, but since now it's not writing, it's okay if you do this mistake as well. As long as you get the inflection point correctly, it's okay. Now this will be 3 by 3. It will be minus 5 by 3. That is all equal to what? 0. So this is all, a single term. So just this remains. You take everything else to the other side. Other side, you just multiply by the reciprocal of the power, 3 by 5. Both the sides, it's 0 only over here. So then what happens over here? Minus 2/3 to the other side will be 0. So everything will be 0. And 3 to the other side will be 3 multiplied by 0. 0 divided by 2 minus both the sides. It will be 0 itself. So it's very easy. And what you're remaining exactly with is 0 1 minus x. So x is equal to 1. That should be the inflection point. Since we know the left side is already going to be dissolved to a constant 0, we can directly look inside the brackets and tell x is 1. That's the point of inflection. Now we have trig functions, sine and cosine. What is the first derivative of sine? Sine is just cosine. It's cosine x, positive. But what about cosine? It's minus. Already there is minus, and then minus sine x. So here we have to multiply the two negative signs. It's going to be cosine x plus sine x. That is the first derivative. I'm going to do the second derivative here. The second derivative is going to be cosine becomes minus sine x plus cosine x. Now let's make this equal to 0. Minus sine x is plus cosine x. Let's use the calculator. But even if you take this to the other side, I can understand sine must be equal to cosine. That's around 45 degree, or along the, if this is the unit circle, let's see, the 45 degrees or 225 degrees. That must be the answer. But let's do it in the calculator. I'll show you how we can do it. All you do is type this out. 0 equals minus sine over here x, close the bracket, plus cosine x, and then close the bracket. Here what you need to do is press shift solve and then equal to, the degree is 45 degrees. Leave it in the default mode. Just clear your calculator and use it as x at x. So whatever answer in terms of degrees is much better, because radians, it'll be, when we are solving it, it won't be accurate. If you're using to solve x value, if you know that, then we have to use radians. But over here it's better to use in degrees itself. So now I know x value is 45 degrees. So x is equal to 45 degrees. Now what happens? Sine and cosine repeats. See, they are, if you know the unit circle from before, it's 0, 90 degrees, 180, then 270. If over here we have two things, even over here after 180 degree, it will repeat itself. The coterminal angles. So if you add 180 to 45, it's 225. Even over there, they both are equal. Sine and cosine are equal. Why I'm talking about sine and cosine being equal is because if I rearrange sine to the other side, it's going to be sine x must be equal to cosine x. When are these equal? At 45 degrees and 225 degrees. The values are same. Here it's negative, negative. Here it's positive, positive. So here that's why we write plus 180 degree times k. K is an integer multiple, like 1, 2, 3 multiples of it. Even, this is 45. Even if you pass 360, again you'll come to the same point. Again you'll come to the same point. So this multiple. So that is the answer. K is 45 degrees. Now here you can see this. Yeah. It's pi by 4. Pi by 4 is 45 degrees. And this k pi means you're adding 180 degree every regularly. So inflection point over here is basically at, what answer we got was 45 degrees plus 180 degrees k, right? Now if you write this in radians, how do we write it in radians, 45 degree? What is 45 degrees in radians? It's pi by 4. I'll show you in calculator. All you need to do is write 45 divided by 180. Now the answer is 1/4, but you have to multiply pi here. Okay, I've not written pi and divide by 180, right? So I've just written this 1/4, but remember it's pi by 4. Just multiply this by pi. So it's pi by 4. Same way, if you do 180 by 180, it's going to be 1. So 1 pi k, and over here it's pi divided by 4. The conversion from degrees to radians. So these are the answers, and that is what we have got. Actually, this must be first, and then you write k pi. That is the repeating interval. So pi by 4 is the correct answer. And if you solve it in degrees, no problem. If your options are in degrees, well and good. If it's not, then make sure you search for you convert it and then search for the correct answer. This problem, we have got tan inverse x squared. So we need to remember the inverse function. The first derivative would be very simple. It's just 1 by 1 plus x squared. See, if it was tan inverse of x only, it's 1 by 1 plus x squared. But here what you have is already a squared, so there is an extra power 2. Then you just have to multiply with whatever is the extra term. Tan inverse is done. It's the chain rule now. This is done. What is the derivative of x squared? It is 2x. So it looks something like this. 2x by 1 plus x to the power 4. Please remember these two terms. Just don't write 1 by 1 plus x power 4. That will be wrong. Chain rule, this is very important. Now it's done, but now we have to do the quotient rule, not the product rule, quotient rule. Here you can write it as u by v or a by b. It's the same. What you need to do is derive the first term. See, above is the numerator. Derive it, multiply it with whatever is down, minus, leave the first term as it is and derive the below term. Divided by whatever is down is squared. So let me do the double derivative. First, below term is just squared up. Okay, that is done. Now what else? Here, whatever is in the above, you will need to derive it. It's 2 multiplied by whatever is down over here. You have to write it as it is. Minus, now 2x remains. And what is the derivative of 1 plus x power 4? It will be 4x power 3. That is derived. Yes, that's it, because it's 0 plus 4x power 3. Now then, let's simplify it, because you cannot just equate this to 0. We have to simplify and get it into reduced form. Denominator is the same. That's fine. Let it be there. That is not so important. The numerator is very important because that will be equal to 0, isn't it? Here this 2 is multiplied inside, so it's going to be 2 plus 2x power 4. Then this also is multiplied, minus 2 times 4 is 8. X and x will be x power 4. Don't think 2 is multiplied to all terms. No, they are single term multiplied. So two numbers with numbers. 8, x and x will be x power 4. Now, yes, we can simplify here. It's going to be 2 minus 6x power 4, because it's like 2 minus 8. Because they are the same coefficient, same variables here. And 1 plus x power 4 the whole square. This is equal to 0. So now what we do is we have to equate both the numerator and the denominator. This is going to be the, asymptotes wherever it's undefined. So let's solve both of them one by one. So first I'm going to use the top one. It's going to be 2 minus 6x power 4 is equal to 0. Let's solve it up. 2 is equal to 6x power 4. Now let's divide both the sides by 6. It's going to be 2 by 6 is equal to x power 4. It's 1/3 x power 4. We need to take root radical 4 both the sides. Now since it's 4 is even, you will have plus or minus here. It's radical 4 1/3. That's going to be the roots. Inflection point. That is equal to x. These are the inflection point. What about the denominator? I'll just do it down over here. It's 1 plus x power 4. The square will cancel off, right? See, the square is there. Let's take square root on both the sides. Square root of 0 is 0. So you're just remaining with 1 plus x power 4 is equal to 0. Let x power 4 be there, equals minus 1. This goes to the other side. Now what happens? It's a even number. If it's square, what is square is equal to minus 1? It's imaginary number. Same way, even number, you cannot do that. You cannot, because you cannot have negative over here. It's not possible. So this is not considered because they're imaginary. There's only these 2 points. They are the inflection points. And these would just be undefined points, so you can ignore them. So the inflection points would be radical root 4 1/3 plus or minus. Yeah, they are the correct answers. You can see it's not clearly done, but that's how we do it over here. I've just done it, right? These are the steps, and you don't need the steps exactly. You need just these answers. So it is radical 4 1/3 plus or minus. So here we go. What about this problem? Again, it's similar. There's just fraction rules. We can use power rule. It's simpler. Why? Because it's not product rule or anything. It is just power rules over here. So first derivative is going to look like this. 4/3 x power 4/3 minus 1 plus 4 times 1/3. And over here we have x power 1/3 minus 1. Let us write 4 by 3 x power it's going to be 1/3 remaining, plus 4 by 3 over here, it's going to be minus 2/3. Now we are derived this again. This is the first derivative only. How about the second derivative? Now see here, the powers are different. We just can't add them up. There are other simplifications. You can remove the common term. What you can do is you can remove this 4/3 out, but still it's the same thing. This is just going to be the constants, So coefficient, they're numbers, so it doesn't matter. I'll write 1/3 down, and now x 1/3 minus 1 plus here 4/3 times minus 2/3, and over here you have minus 2/3 minus 1. So what's going to happen is it's going to be 4 by 9 here, x power minus 2/3, plus here it's going to be 8 by 9 minus 8 by 9. Let me just change the sign. 8 by 9 x, it's going to be minus 5 by 3. So this is all equal to 0. We can't just make it equal to 0 because we need to simplify this. And I can see the numbers 4 by 9. I can remove 1 by 9 for sure. 9 can come out and 4 can come out. So, but still this x's, I need to get them, simplified, like write it in terms positive roots, or I can write it as 1 by x 2/3. Take something out, what is common. Looking at these, I can definitely tell this is common, right? 2/3 is already there in this as well. Let me write it out over here. X minus 2/3. Over here, what's remaining? It's just 2. And this can be written as x minus 2/3 into x minus 1. Why is this? Because if you add them up, 2/3 we just did it up above, right? Minus 2/3 minus 1. If you add this minus 1 over here power, when you add these up, the powers are added up, it's going to be negative 5 by 3. So you can write, you can leave it like this only. Even over here, when you're doing this step, you can leave it out. You can leave or split this powers. You can write this minus 2/3 into x minus 1. Because when they are multiplied, the powers are added, the bases are same. So here I can remove this out, but remember this has negative power, so I'll take it as down, it'll be positive power. And here 1 is remaining, minus 2, and this is gone. See, these two are gone outside. I've removed it common outside. So what is remaining? It's x minus 1. I'll write it as 1 by 2x. This is all equal to 0. This entire thing cancels off. When you take it to the other side, it's 0. What remains is 1 by 2x will be equal to 0. That is 1 is equal to 2 by x. Take this x to the other side, x is equal to 2. So this is the point of inflection, it's 2. So let me just run through this. Here we derived it once. First time was pretty simple. When we derive it for the second time, we are gonna get 4 by 3 times 1/3 x, whatever is the power minus 1. This has happened over here. And then 4 by thirds times minus 2/3. This is minus 2/3 x to the power minus 2/3 minus 1. Next, what we do is we multiply all the numbers. 4/3 times 1/3 is 4 by 9. Here 4/3 times minus 2 by thirds is minus 8 by 9. What about the powers? 1/3 minus 1 is minus 2/3. Here you can leave it like this because I'll just write over here minus 2/3 minus 1. You can write it as same base is the same, minus 2/3 x minus 1. You can write it like this as well. Or if you solve this, if you just put this in the calculator, you're going to get negative 5/3. So now here I need to remove whatever is common term and get the simplified form and make it equal to 0. So what is going out? 4 by 9 is going out because this 4 by 9, this is 9 is gone, but 4, instead of 4 we have 8, so 4 times 2 is 8. 4 goes, see here, it's basically 4 by 9 and we have 8 by 9. So here 4 by 9 remains minus here 4 by 9 times 2. Why? Because 4 by 9 times 2 is 8 by 9, isn't it? So that's why I can take 4 by 9 outside and you're remaining with 1 minus 2 for the numbers. Then here We have x power 2 minus 2 thirds, which is equal to x power minus 2 thirds is basically 1 by x 2 thirds itself. I hope this is clear before itself. Now here what happens is, instead of writing minus 5 by thirds, we know it was minus 2 thirds and minus 1. So I split it out and I can remove these two common outside. And that's also gone. So only thing that's remaining is 1 minus 2 by x. And then 1 minus 2 by x equals 0. I've solved it up over here. It's very simple. Minus 2 by x to the other side becomes positive 2 by x, and x to the other side, you know, it's already 1, so it'll be 1 times x, that is 2. So the point of inflection over here for this particular problem is at 2. Here we can see the answer as well. This is the answer. It's written 0, 2, but the actual thing is 2. From here we need to equate it to 0 and then do it. So that's how we do it. Since there is no need of writing anything, you can, do your own methods. But this is pretty long because there's no shortcut or direct method. But I hope this is clear. I hope in the exam it'll be an easier problem rather than this. Now here it's just the product rule, and it's not that difficult because we have e exponential are very simple to solve. So the first derivative would be, now it's if it's a and b, it is a derivative b plus a b derivative. This is the product rule, a simple rule. Comparatively it's simple. So x derivative is 1 e to the power minus 4x, plus we have to write x, that is as it is, because over here first time we derived x, that was 1. Now second time we write x as it is and derive b. What is happening here? It'll be e to the power minus 4x itself, but don't forget the chain rule. Whatever is up, we also derive that. It'll be minus 4. So now let's simplify this. F derivative of x, we'll get e to the power minus 4x minus, see, 4 times x, e to the power minus 4x. Now I'm not going to leave it like this because again product rule and everything. Let me take these two terms outside, because even if I don't take, I'll have a product rule here. It's going to be complicated, but I know these two are same. So e to the power minus 4x. So what is remaining? 1 minus 4x is remaining. Okay, this is also a little bit complicated now, I realize. Now we have to double derive it, and it's going to be product rule again. So first time when we derive this, it's going to be e minus 4x times minus 4 multiplied with the second term will remain same. Now I just derived the first term which I got over here, second term same, that is with b, plus, did I write? Yeah, we have written plus, then minus a chain. Now this term, I'll write it as same, e minus 4x, but what happens is I derive the second term only. It's going to be, see, this is 0 minus 4 because x is going to be 1, right? It's going to be minus 4. This is the answer. And now we need to rearrange it how much we can. So it's over here, it is minus 4 e to the power minus 4x multiplied with 1 minus 4x, and here also it's minus 4 e to the power minus 4x. So we have just written it over here. Now we can take this two common outside, though they are, this is like a x minus a. So I can remove a outside. It's going to be x minus 1, isn't it? But it's minus minus, so I'll just remove minus also outside. It's going to be plus. So it's like minus a. Imagine this is minus a. This is x. Minus a again. So minus a is removed outside. You're remaining with x plus 1. So here I'm going to remove minus 4 e power minus 4x outside. And you're remaining with, this term is gone. So you're remaining here with 1 minus 4x. And this is also gone. So it's plus 1. I hope this is clear. Look at this. This term is considered to be minus a. This is again minus a over here. And you have x. And this is a single term minus this term. So I can remove 4e power minus 4x as common term. I can remove a outside. You're supposed to remain with, I'll use a bigger bracket because that is removed outside. So this is the bigger bracket. Your minus a is written out. So what's remaining is x. X is 1 minus 4x plus 1. Next, here what happens is you can simplify. This is going to be minus 4 e to the power minus 4x. What happens here? It's 1, 1. It's not going to cancel. Sorry, my bad. It's plus. So 1 plus 1 is 2 minus 4x. That's remaining. This is all equal to 0. When you take this to the other side, this all dissolves. Now, what about this? It's going to be 2 minus 4x is equal to 0. Let's solve it up. It'll be 2 is equal to 4x. Divide both the sides by 4. It's 2 4 is equal to x. That is 1 by 2, right? 2 by 4 is half. So the critical inflection point must be at half. And yes, that's the point. So this is the actual method to solve, and you need to solve it, guys. You need to double derive. There is no shortcuts because your calculator can give you one derivative. The graphing method will not give you enough information. It's very, very difficult to find the inflection point. And maybe some problems, yes, but majority of the problem, the graphing mode 7 method will not give you the inflection point. It doesn't, because imagine this is the inflection. See, inflection point is somewhere over here. How would you know? It's just decreasing. If it's increasing or decreasing, critical numbers, yes, can be found out from graph, but not this inflection point. So it is very important for you to double derive it and then get the answer. I hope polynomial problem come, they are simple to solve. If it's such problem, you need to be careful while deriving it twice and then equate it to 0 over here. They have removed common terms. Any method we do, as long as you've done it correctly, it's fine. Over here, this is the answer. They have removed another 2 outside, so that's why they've got this answer. But what I have done is also absolutely correct. The same answer we have. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we are going to determine concavity and the inflection points from a graph. It's from the lesson 4.5. You will be given graphs here and you need to know where is it increasing, decreasing. They've asked you increase, decrease, and the concavity. And the most important thing is the point of inflections. If you're thinking the inflection point is over here, it's in the center, isn't it? No, that is wrong. Why? Because many of us tend to think it's somewhere over here. Let's look carefully. Let's analyze this. You can easily tell it's dipping down over here. This is the dipping point. This is the increased most high point, and then there's an also decreasing. Then it keeps on going. Now, if you see decreases till here, then it starts increasing here, decrease, increase. Okay, that is about increasing and decreasing. So let me get the points out. So increasing and then decreasing. Most probably this question will be about concavity, which I'm going to do it in a minute. And the minimum points will be these two, minimum, max. All are relative minimum and maximums. So minimum would be plus and minus 1 because this is 2, 1, 0. And max is 0. Increasing from it's decreasing here. Increasing from minus 1 to 0. Then from 1, this is 1 interval, 1 to infinity. Whereas it's decreasing from minus infinity to minus 1 and from 0 to 1. You can see that's what's happening. What about concavity? What is the point of inflection? Where is it concaving? Concave up, concave down. So down and then inflection point. So where are these exactly? Let's look into it. So it's coming, this is all concaving upwards, right? Upwards is like this. So yes, it's looking upwards, upwards. It'll be looking upwards somewhere over here, because then you can see it's looking downwards. Over here it's down, but till over here somewhere it's up. So it's in between, you can say 0 and 1, because this is 1, this is 0. Somewhere in between here, up and down changes. Same thing here, it's down and then it's up. See, it's somewhere over here it changes. So it's in between this. It is 0.5 and 0.5. I can approximately tell it to be plus or minus 0.5. Since you have not been given any other equations or anything, so don't worry, your options won't be like 0.5, 0.6, not like that. You will have 0.5, 1, 2, something like that. It's easily differentiable. So this is plus or minus 0.5 here. And where is it concaving upwards? It's concaving up from minus infinity till minus 0.5, and it's also concaving up over here from 0.5 till infinity. Whereas where is it concaving down? From minus 0.5 to 0.5, it is concaving down. See, this is the only part it's going down, and then all it's up. So just by looking at the graph, you can tell you should focus on the points where it's turning. So over here they have told, see, concaving up, we have written minus, and this is correct, and this is correct, and it's down at minus 0.5 to 5. Where is it increasing? Decreasing over here is minus infinity to 1. Let me just check. Minus infinity to minus 1. Sorry, this is wrong here. This cannot be 1. It's decreasing from minus infinity to minus 1, and 0 to 1 decrease. Increasing, see over here, minus 1 to 0 and 1 to infinity. Sorry for this error. And it has maximum at 0, minimum, local minimum is over here, minus 1 and plus 1. Inflection points is minus 0.5 and positive 0.5. Another graph. Please do pause the video, try this by yourselves, and then continue with the explanation. Here you can see the relative max, relative minimum. Those are maximum minimum points. Where is inflection? See, this is all concaving down, down. Somewhere here it changes, because then it's concaving up, isn't it? So concave up, cave up will be, it's 0, 1, 2, so it's somewhere at 1, 1 to infinity, concaving up. Down would be minus infinity to 1. This is 1. So 1 to infinity would be upwards, downwards would be minus infinity to 1. Inflection point would be somewhere at 1, because we have already mentioned it. It's at 1 over here. And what else? Maximum point is at 0, max is at 0, minimum is at 2. And where is it increasing? It's increasing from minus infinity till 0, and again from 2 until infinity it's increasing. Whereas decreasing is only from 0 to 2. That's the only decreasing point. Everything is visible in the graph. So we can look into the answers here. Concaving up, as you can see, from 1 to infinity, whereas downwards it's minus infinity to 1. And then increasing on the intervals, increasing from minus infinity to 0 and from 2 to infinity, whereas decreases from 0 to 2. And the inflection point is at 1. Maximum minimum is not mentioned, but relative maximum is over here, local max 0, minimum is at 2. In this question, we have to sketch graphs of a given function using the properties of first and the second derivatives. It's from the lesson 4.6. I will directly tell you a shortcut method for this. They have told you x is 1, x is 2, y is 3, and so on. They've given you the asymptotes basically. So which is the correct equation? For this, if you have the 4 options, imagine you have the 4 options, it's very, very easy. Because over here, x means the denominator, right? It's undefined at that particular value. So over here, if x is 1, so at 1, there is an asymptote. x1 asymptote, x2 also there's an asymptote. Here, there can't be any graph. Even if there is a graph, it will just go very close, but not at those points. That's an asymptote point. I'll show you the graphs in graphing calculator in a minute after I explain these problems. But you will have your 4 options. Just carefully analyze which is the correct one. Over here, x is 1. So take it inside and write it as a factor. It will be x minus 1, x minus 2 in this case. What about this? It will be x plus 1, x minus 1. Here we will have x minus 1 and this 3. Not the y, only the x values. Okay, x minus 3. What about this one? It's x plus 1, x minus 1. These x asymptotes are always along the x-axis, the denominator. They make the function undefined values, isn't it? So look at the denominators. Whatever you have, x will always be in the denominator. The y is in the numerator, which I'll tell you in a minute. Now let's carefully analyze these. Now I'll come in a minute for the square root. You can easily understand from the question which is a square root function and which is not. First thing, here it's minus 1, minus 2. Okay, this can be the answer. What if there are two options with this? If this x divided by the same denominators, how would you differentiate? That is from the y asymptotes, which I'll tell you in a minute. But let's look over here and here. Are these the same? Of course, because you have a plus b, a minus b rule or identity, isn't it? It'll be a squared minus b squared. Or a squared minus b squared is equal to a plus b, a minus b. If you have these two, you can multiply them by FOIL method and then you will reduce it to this. It'll be x squared. I can directly use the identity minus 1 squared, that is 1. Or if I start multiplying, it'll be x squared minus x, then again plus x minus 1. This cancels out, you're remaining with x squared minus 1. Therefore, we have this denominator. What about the fourth question over here? X minus 1, x minus 3. Yes, that's correct. Now here also it's correct. So the first thing would be the denominators, and easily you can eliminate many options just by looking at the denominators. I hope the denominators is clear. Now let's go to the numerators. What about the numerator? Here there are few things you must remember. Whenever you have x power 2, that is quadratic, whatever is the coefficient, what is the coefficient over here? It's here 3, provided there are two denominators, okay? Because most of the time you will have x degree 2 only, okay? So now the degree is 2, this is also 2. Whatever is the coefficient of this x squared is y. Even over here you can see this is x power 2. So what is y? Y must be 2. Imagine you had something like this, minus 5x squared by x squared minus 1 squared, or 1 is enough. Now what is the coefficient over here? Because it's x squared down, x squared, it'll be minus y is equal to minus 5. This is the, that's the y asymptote. Now what about this one here? Whenever the degree is less in the top, the denominator is more, y will always be 0. Look here, whenever the x is there, the coefficient doesn't matter, it's 1. Even if it was minus 10 here, it would be y is equal to 0, which I'll show in the graphing calculator in a minute. Now if it was 5 here also, it will be y equals 0. So this is how you differentiate between these. You've been only given up to quadratics, because cubic will be just more complicated. You would have, you know, slanted asymptotes and everything. But what about these square root one? Whenever there is a square root in the denominator, just remember, up doesn't matter, it's x. Here, whatever is this coefficient, you should write plus or minus 2. If in case you had over here, say 7, it would be y is equal to plus or minus 7. That's how we do it. So now let's understand this thoroughly using a graphing calculator. I hope this is clear, because over here, denominator, you have x minus 1, x minus 2, and y is the coefficient 3. Y is 3, so that's why this is the correct answer. You can easily eliminate all the other options. This is wrong because there's square root. This is having 2 here, and this is having only x here. And whereas if you look at this question, only this is the possible answer. Only this. You can have a little different answer as well. Over here, I can have 3 as well. Therefore, it is very important for you to look into all the 4 options and then eliminate and get the correct answer. Now, let's go to the graphing calculator for a minute. Now, you can see I have written some equations here. Let's look at this ax squared divided by x minus b, x minus c. The numerator, the y value is 1. If I just change this to any value, say 8.6, now then the asymptote at y is equal to will be 8.6. As you can see, the y value, it eventually goes to 8.6. If you zoom out, you can see the y value is going closer and closer to 8.6. Even over here, it'll be the same thing. Let's go back, say a reasonable. Over here, if you go negative numbers, it'll be negative. Let's leave that at say 2. What about these? These are the x asymptotes. Now if I go the undefined values over here, that is at x. Over here it should be at 1. Let me just change this and make it minus. So over here we go. Since I've written this minus already, over here 10 would be 10. If it was plus here, it'd be other way around. Imagine, let me take it as plus and plus. Everywhere let me take it as plus. So now if it's plus 10, it'll be at minus. Can you see this? It's at minus 10. And if it has plus minus 5.7, it'll be plus 5.7. That's how we get the answers over here. And similarly, let's go to the cubic one. Cubic one, see, as I told you, it'll have horizontal asymptote, oblique asymptotes. So you can leave this, it's not asked generally, but it'll be the similar thing. Over here, the down denominator asymptotes won't change. It'll be the same denominator. These are the undefined values. Denominator is the same. So let's leave that. Let's go to the square root one. Now here we have these asymptotes. These asymptotes will be same, B and C. You can see over here it's undefined over there. So those will be the same. But what about this A value? If you have, say, A value of 10, let me take 10. You will have not only 1 plus 10, you will also have minus 10. So this is the difference. Now what if you have negative values? Say you have negative 10, negative 8. So then you will have the same thing. Minus over here plus 8, one is plus 8, one is minus 8. And what if there is no square root? It's just 1 x to the power 1 over here. But down there is 2, degree 2, so over here the asymptote will only be at 0. If you zoom out, you can see it doesn't matter which coefficient you have, A, doesn't matter over here, it'll always be at 0 itself. So that is how we can differentiate, and denominator, it doesn't change, that'll be the same thing. So this is how we can analyze it from the graph as well. Most importantly, to solve these problems, just look into the options, eliminate the options, and then choose the correct answer. Question 9 is to find the antiderivative. It is from lesson 5.1. Here we have to use the rules of antiderivatives, or it is also known as integration, to solve. Let me first solve a couple of problems and then I will teach you a calculator method only for the electronic part. Since this is an electronic part, we can use it. All the 4 options must be available and then you can use the calculator method. The power rule states whatever is the power is added by 1 and that newly formed number is divided by over here. So it will be 3x to the power 5 divided by 5 minus 3 as it is, but this is x power 1 becomes 2 divided by 2 and we write plus c. C is the constant of integration. That's the answer. Here it will be x power 4 by 4 minus 2x. If there's nothing, we just add an x. What if it's square root? It's power half. So you can consider this to be half, and over here this can go up and it'll become minus 4. Now integration of this is what we are doing. So this will be x. You can even write 0.5, doesn't matter, but your option won't be according to 0.5. It will be in terms of square root itself. For understanding's sake, you can write over here and solve it. Now what I'll do is I'll add half with 1. If you do it in the calculator, you'll get 3 by 2. That's 1.5. And over here also I'll do 3 by 2. Minus, here when you add 1, it will be minus 3 by minus 3 plus c. But this won't be in your option. If you look in your option, say this, it's something like this. Okay, it's not in terms of square root or cube or anything, but still it is not exactly this, right? What they have done is they have simplified. Let me show you what is simplified. Here, this 3 and 3 cancels off, and this is in the denominator which goes to the numerator, right? It will be 2x 3 by 2. Minus and minus becomes plus x minus 3 by 3 plus c. Now, why is this so? See, over here it is a divided by b by c. This is equal to a multiplied by c by b, isn't it? So if these both can be cancelled, so that is what I've done. This will be multiplied. Now look here, this may not be the final answer. In your options, you may not have this. You might have, see here, this is square root x, and it is raised to the power 3 plus 1 by 3x cubed plus c. This is also a possible solution. What did I do is I wrote t2 as it is, square root. Why? Because this is divided by 2, right? It's square root x power 3, and this I took it down to make the power positive. Similarly, you can solve the others. If it is trigonometry, you are use the trigonometric identities. But now let me show you the calculator method. For that, you need to have the 4 options. Let me use these as the options and let me solve it. So in order to solve in calculator, first, you need to look into this given question. Not with the options, first the question, and then choose any x value. See, now I'll type this question as it is, 3 alpha x to the power 4 minus 3x by alpha x. After I type this out, I need to calculate at a certain value. What value should I calculate? Please don't choose negative numbers, don't choose 0, and don't choose 1. Anything other than that. You can choose 1.5. I usually go with 2. It's very simple to remember. Here we got 42 when we used x as 2. So write it out somewhere at x equals 2. The equation, just write like this, it's 42. Now what we will do is we will derive these 4 equations. Why? Because we know when we integrate we'll get this answer, but when we derive we should get this question back, isn't it? So if we derive all these 4 options and then use the x value as 2, shift and integral symbol gives you derivation, right? Here, what is the x value I just chose? X is 2. Now I will have to type this out, all these options. Now when I solve this up at x is equal to 2, I must get 42. In your exam, you'll have 4 different options. Whichever you solve will give you the same answer as the question. That is the answer. Look, what happens with the c? When you derive any constant, it's 0. So this is cancelled off. So that is why we can derive it and easily get back the answer, the value over here. Let's do it. 3 by 5 x to the power, sorry, to the power 5 minus 3 by 2 x squared. Now, if you want, you can write any plus 5. Imagine I write plus 5. The answer is 42. What if I write something like minus over here? It's again 42. And what if I just don't write any constant? That c means any constant, any number, right? It's the same answer. Why? Because derivation of any number is 0. So that's gone off. Now over here you can see it's 42. So this is the correct option. But in your exam you'll have 4 options you need to check with all the others. There won't be 2 common answers. You won't get any other value which gives you 42. If that happens, that means there are 2 answers. So that will never happen. So you can easily use this when there are 4 options, only in the electronic part. Now here let me do the next one as well. Over here as well, what I'll do is I'll just do shift dy by dx 1 by 4 x raised to the power 4, and we have minus 2x. What is the x value? I always take 2. You can take 1.5, 2.5, 3, 5, 10, anything. It's better to take a simpler value, but we cannot take 1, anything other than 1. So what is the answer? Here I got 6. Now, since we have only one option, this is the correct answer. Now, if you type this out, x to the power 3 minus 2, and calculate this. Sorry, I have not written minus 2. Calculate this at x is equal to 2, you will get 6. You have to, otherwise it's not correct. So whatever answer you get correctly will match with the question. So when you derive this answer, you must get whatever the x value you put over here. So please do try for all the problems. Let me do the last one over here. So here we have 2x raised to minus 2 plus
1 divided by square root x, that is alpha x, calculated at 2, you get 1 plus root 2 by 2, and it's 1.2. So the same thing must be obtained over here. Let me derive this minus 2 x raised to minus 1 plus x raised to half, that is 1 by 2, or 0.5 is also fine. You do not need to write anything for c, and you can see here this one is 1.207. Now how would you understand in the fraction form? If you just press on answer, if you press equal to, okay, over here it's just the SD doesn't work, but whatever we got over here, when we had pressed SD, it's the same value. So make sure in your exam you write the decimal point. Always write the decimal, not the fraction form. So if you put over here, we had just done it, and when we pressed SD for the fraction form, we got the same answer. So use the decimals. Here as well, you can do the same thing. I will try solving some um, trigonometric functions. These are all the same, but this trigonometric function, let us first type it out. Now here, whenever you have trigonometric function, make sure you change the mode. Let me show it in the degree mode and then let me change it. It's 2 sine x plus cosine x. Okay, close the bracket, calculate it at 2. Now this is 1.069, but let me change the mode, shift mode and forward, that is for radians. Now look at the answer, it's absolutely different, isn't it? It's 1.402. Remember, your trigonometric functions cannot be solved in degree modes, it must be in radian. Okay, so now here then, 2 sine x plus cos x, the given question I typed it in, calculated at 2, it's 1.4. So we should know all the 4 options. Now here, this is the answer, right? Let me derive it. Shift dy by dx minus 2 cosine x. And then we have plus sine x. That's it. I'm not going to write c. Why? Because it's going to dissolve anyways. And x value must be 2. And it's in radian mode itself. It's the same answer. But if I change the mode to degrees here, look at this. It's absolutely different. The degree value for the question and the answer doesn't match at all. Only the radians will give you the accurate answer. It's 4, shift more and 4 to get radians, and then you get the correct answer. Only for trigonometry, just make sure you convert it to radian mode. But anyways, if you don't convert as well, all the 4 options will be wrong. When you cannot get any correct answer, then you must realize, okay, you will realize for sure, okay, I've done something wrong with the mode. But instead of wasting the time, just make sure you press the mode, get into radian and do it. And why do I say do the answer question first and then the options? Because over here, when you solve the question, you'll already get the answer. Then when you solve any one of the option, you can just match with the answer obtained. Here now, what to do if it's secant? You need to know all the 4 options. Secant also can be solved in the calculator, but make sure you're writing the reciprocal identity. Secant is 1 divided by cosine. If it is s over here, it'll be 1 by cosine. If it was cosecant, it'll be 1 by sine. Divided by x, close the bracket, then write multiplication symbol and tan x. Calculated at 2, what is the value? 10.50. Now when you derive over here, what you must get, 2 divided by secant is cosine x, close the bracket, x of 2 is 10.50. If you look into the 15th problem, there was an issue because I was solving this just a while ago and it didn't work out. I edited the part. The reason being these questions both are different. Now I will solve this here. First, let me find the correct answer. When you integrate phi, it's a constant, let it be as it is. But what is secant square x integration? It is tan x. So it'll be tan x plus c. This is the correct answer. Whereas over here, what happened is you have secant squared 4x. So what happens is phi, it'll be tan 4x and divided by 4. So that is why now we will solve both of these. So first one, you need to calculate the given question phi. How do you do square? Make sure you write phi multiplied by, open the bracket, fraction 1 by secant square is cosine. Cosine x, close the bracket here, square it up, and now calculate it at 2. The answer is 28.87. Now, if you want to avoid all these brackets, you can write it like this as well. See, without the brackets, just make sure you can't put it over here, the square, not over here, not for this x, it'll be x squared. Then go outside after closing the x, close the bracket, go outside and then square it up and then calculate it at 2. Yes, it'll be the same thing. So there are two ways, but I would ask you to stick to the bracket method because it'll work in other complicated problems where brackets are really required. So this is how we do it. Now, how would we derive it? Derivation is this answer, right? Shift dy by dx. Let's do phi tan is over here, x, that's it, plus c is a constant, you don't use it, x is 2, it's 28.87 itself. Now what about this one here? Let me first do the answer because I've already written it out over here. Tan 4x, and over here we have phi divided by, okay, I shouldn't have done that, it's phi by 4. So let me do like this, phi by 4 multiplied by tan x. It's 236.18. Now, what if I write phi multiplied by, let me use the brackets, 1, oh yeah, bracket 1 by secant is cosine. It's not cos inverse, it's just cos. Now, it's not only x, you can see it is 4x. So make sure you write 4x and then close the bracket, close one more bracket and then square it up. Calculate it at 2. The value is 236.180. So this is how we solve it. Any problem can be solved even over here, these and everything. Even if it's square root, it's the same thing. Let me solve this out quickly. 4 divided by square root 1 minus x squared. Okay, here calculated at 2. Now I'm getting a math error. Why? Because here if you put 2, it'll be negative numbers. So make sure when in such problems you should make sure you avoid the numbers which make this infinity or undefined. Now I cannot put 2. Now what about 1? If I put 1, it's going to be 0. That will also not give me the correct answer. In such cases I have to put 1 minus any number less than 1. So in such cases, just remember x value cannot be taken 2 or more than 1. I'll take it as 0.5, calculate it at 0.5. The calculator is going to do the calculations for you, so there's no problem at all. I've taken 0.5, it's 4.618. It should be in radian mode itself. Now let me solve this out. Here it is shift dy by dx. You have 4. Arc sine means it's sine inverse. Press shift and sine and then press alpha x, close the bracket. Now it's not 2 here. You'll get undefined at 2. Obviously it's a math error because we got 2 undefined just a while ago. It's 0.5. Now you can see that is the correct answer. In such cases, whenever you get math error in one of this, that means that is not allowed. The domain doesn't allow that value for x. So change the value. Make sure you look over here. 1 minus x squared. And we have square root. So x cannot be negative. I mean, this denominator cannot be negative inside the square root. So take a value which is less than 1. You can take 0.9, 0.5, 0.75, 0.25. That's absolutely fine. I've taken 0.5 and both the side the numbers match. Similarly, please do solve the other problems. There's nothing difficult over here. E power x, that is also available in the calculator itself. So let me solve these two over here. At the left side, these right sides are similar. Here first 3, shift and ln gives you e, or you can even press alpha and this symbol and then you need to raise it to the power. Over here, x minus 2 calculated at, I'm going to calculate it at 2 for now. Okay, it's 20.167. Now what about this shift dy by dx? Here it is 3 e to the power, that is shift and ln, e to the power x minus 2x. Okay, now I've written everything to the power. That's wrong. After the power, press next and now subtracted by 2x. X value is calculated at 2 and the answer is same. Now what about this one here? So I'll first write 3 cosine x minus, close the bracket, minus 1 divided by x. I don't write anything else, just calculate it at 2. The answer is negative 1.748. Now here, shift dy by dx, 3 sine x. The first part is very easy. Minus, what is this? Ln x. And now when we write over here 2, you're going to get the same answer. If you're thinking, why is this modulus, that also can be given to, you can type it out by pressing shift and hyp. Can you see this? And then put alpha x, and I'll just remove this x. That is also possible. This modulus is by shift and hyp gives you absolute value. Now x is 2, the answer is same. Okay. So this is how we solve these problems, and all the others are just similar, be it square root, all are very straightforward. Here you won't have any problem with the x value because it's 2 is positive, x is positive, you can have anything. You can just stick to 2. Most of the time stick to 2, it's going to work almost everywhere. Over here, just make sure ln x. See, since you're taking 2, it doesn't matter, the modulus doesn't matter at all. Why? Because you're taking a positive value itself. Only if it was negative value, then yes, this needs to be put and all that. Yeah, even in the previous problem when we solved ln x, you're considering x of 2, so it's not going to make any difference. Positive numbers will be positive itself, it's inside the modulus, only negative numbers change. So that is why I've already told you, when you're assuming x, make sure it is not negative numbers, not 0, and please don't take any undefined values. If you get a math error, just change it. So take 2 most of the time, that's gonna work. So here, these are the answers. Similarly, please do try all of these by yourselves and then check. These are huge, lengthy to put in the calculator, but they are very, very simple to solve. There's no issues over here. Even over here, you can just take x of 2. Anywhere you get a math error, just change the x value. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. Question 10 is also about antiderivatives. It's from lesson 5.1, but here we find the constant of integration, the C value. Before I continue, many students get confused. What is this f of x, f dash of x? Like, how exactly can you understand this? So let me take an example, x power 2. Let me integrate this. What is the answer? The integration will be x power 3 by 3 plus c. Okay, imagine I'll consider this as the function f of x. Now, what is the derivation f dash of x? This is f of x. Derivation would be this 3 comes down and it reduces by 2 divided by 3 itself. This was already there, plus constant of any number, right? Constant 0. It cancels off. What's remaining? F derivative of x is x power 2. So this is the question. So this is f dash of x. So whenever they have given you this here, f dash of x, and then they tell you to find f of x, that means you are integrating this. So when you have a derived function, when you integrate it, you will get the function before it, that is f of x function. Here then we have f of 0 is equal to 4. Once you derive, see, let me just solve this quickly here. You have 3e to the power x plus x squared by 2 plus c. This is what? F of x, because we integrated this, anti-derived. And then now what is given? F of 0. If we consider all the x values to be 0, what happens? It will be 3 to the power 0 plus 0 squared by 2 plus c. What is f of 0 value? It is 4. That means over here we have 3 into e to the power 0 is 1 plus 0 plus c. This is 3. So let's take 3 to the other side. It will be 4 minus 3 is equal to c, or 1 is equal to c. So the constant of integration is 1, and the final answer over here would be f of x is equal to 3 e to the power x plus x squared by 2. But instead of writing c, what do we write? 1, because they have told this particular function at the point 0, x is 0 and y is 4, right? So that will be the final answer. You can see here it's 3 e to the power x plus x squared by 2 plus 1. So that is the method. But even over here, you can easily solve it in the calculator. How can we do that? You need to know all the four options, and since it's the electronic part, yes, you can easily solve it up. Let's take our calculators and see how to do it. Here now, the options can be four different options altogether, or you might have two similar answers, but only the C value might vary because the C value is found from this, right? I tell you to solve both of them. No matter what, this part, leave the constant. Only the C is the issue, right? C is found from this. These parts will match the given question. Why? Let me show you. Let me first put the given question 3e to the power x plus x. And what do? We'll calculate this at 2. And what is the answer? It's 24.167. Now, if I derive this, let me derive all the three options. You can ignore the constant or put the constant. It's absolutely fine. 3e to the power x plus x squared, that is alpha x squared by 2 plus 1, and x value will be 2. It will be the same. It's 24.167. So now this is the correct answer, yes. But what if you have one more option, say like this? You have the same thing, 3e to the power x plus x squared by 2 minus 1. This is also there. Now if you just change this over here to minus 1, let me just change it properly, minus, not 11, minus 1, it's going to give me the same answer. So now this is the issue, which is the correct one? So of course you can eliminate a lot of options by the calculator method, but not all in such cases. So what do is, you see which have these two terms same, and then you need to use this particular equation in the first two terms only, not the constant term. So in the first two terms of this or this, it should be the same, right? What I'll do is, I'll type 4 will be equal to whatever these two terms, wherever x is there, the constant, just ignore it. Constant will become c here, both the cases, plus. Oh, don't write minus, it's always plus here, okay? Because whatever is c, c can be minus, but this we just add it to it. Now here, e to the power x, what is x value? X is 0 plus, again 0 square plus 2 plus c. Now this is 0 over here, it's 3, so take the 3, 4 minus 3 equals c. The answer is 1. So that is the thing. Now if you're thinking in deeply, you can argue, why can't this be minus? Even if this is minus c, it is absolutely correct. Yes, it's, of course it's correct. So such problem should not come, such option should not come. But just in case if it comes, make sure you take this plus c, because we generally take it as plus c. But even if you take minus c, it should be absolutely correct. It doesn't matter, the constant can be any constant. But at this instant, but since we are given over here, just consider plus c when you're solving. Let's do this one as well. So here, let's take our calculators. First thing, I'll just type the given question over here. That is 4 cosine, sorry, no need of shift or anything, just cosine x. That's it. Now what is the value if we calculate it at 2? Is this correct? Yes, because it's already in radian mode. The calculate, see, it's in radian mode. It will be the correct answer itself. But make sure when you're solving these calculator problems, I mean the calculator tricks, always stick to radian mode because you might have cosine, sine. Doesn't matter these values, you will get the correct answer in radian as well. If it's e to the power x and everything, you will get the correct answer. So just keep the radian mode on. Now, next thing, here, okay, this is the correct answer, right? Let me derive it. 4 sine x. I'm not going to put the constant. Even if I put it, doesn't make a difference. It's the same answer. So this is correct. Now, if the constant is different, then I will see this is given to us. So here it will be 3 equals to 4 sine, what is x value? It's 0. Now how would we solve it? What is sine 0? Okay, this is plus c. I forgot that. Sine 0 is 0. So it's 0 plus c is equal to 3. So 3 is equal to c. This is the correct answer. So c value is 3. That's why we added 3 here. It's like 70%, 80% of the chances that all your 4 options will be different. You should not have the same. Okay, you must have different options, but just in case there are 2 options with 4 sine x, then make sure you do this. Here again, now here it's not a direct thing. I mean, it's the same method, but you have to double derive. Now, in such cases, there is no way you can use calculator, sadly. But double derivation problems won't be complicated, they'll be simpler. Okay, here you have to use antiderivative rules and solve, because look, the answer is f of x. There is no way you can jump over here. Whatever you do, derive anything, you can't get 2 steps ahead. In your calculator, you can just make 1 step behind. So if it was only once derivative, yes, you can get that, but not twice. Now let me solve this here. First thing, integrate f double derivative of x. That should give you f dash of x or f prime of x. So let me integrate it. Directly I'll write over here because it's electronic. You do not need any steps. It'll be 12x to the power 3 by 3 plus 2e to the power x itself plus c. Now this is going to cancel out and become fx to the power 3 plus 2e to the power x plus c. Now, what is the C value? This is important before you go to the next step. Because why? Next step, again, we have to integrate it. Any constant will get an x term, isn't it? So here, I will substitute x of 0 and this answer equals to 2. So 2 will be equal to 4x power, sorry, not x power, it's 0 power. This all x values become 0 power 3. Plus 2e to the power 0 plus c. This cancels off because it's 0. Here we have only 2. So 2 equals 2 plus c. 2 to the other side will be 0 is equal to c. So here this is 0, or you can just write this much only. So this is it. This is f prime of x single dash. Now again, let us integrate f prime of x and you will get f of x. So we are double times integrating it. So now let's integrate the above one. It will be 4x power 4 by 4 plus 2e to the power x itself. But then this plus c here, this cancels off. You have x power 4 plus 2e to the power x plus c. Now here, what is the second condition for f of 0? For f prime of 0, we had 2. F of 0, we have 3. So here 3 equals 0 to the power 4 plus 2e to the power 0 plus c. Now we will cancel this 0 off, and this is 2 into 1 because e to the power 0 is 1. Anything raised to the power 0 is 1. 3 minus 2 is equal to c, that is 1 equals c. So the final answer for f prime of 0 is x power 4 plus 2e to the power x plus 1. So this is the correct answer. There is no way you can jump in the calculator from here to here. So make sure you get the correct answer, because in your calculator, if you use the calculator method, you'll just get a single value. You won't get equations. So you can't jump from here directly to 2 times before. So you need to solve them. Again, here as well, let's quickly solve this out. I'm just gonna solve it 20. Okay, it's gonna be f prime of x, that is equal to 20x to the power 4 by 4 plus 2. Now here we have e to the power 2x, but there's 2, so it'll be divided by 2, isn't it? Plus c. So here the simplified version would be x power 4 plus e to the power 2x plus c. Now we have minus 3 equals, the first part is going to be 0, second part is going to be 1. I directly write e to the power 2 times 0 will be 1 plus c. Why? Because over here we have to substitute 0. 0 raised to power anything is 0, multiplied by 0 is 0, it's gone. E to the power 2 times 0 will be e power 0, that is 1 plus c. Take it to the other side, it will be minus 4 plus c, because 1 becomes minus 1 to the other side. This value will substitute it back. That's going to be f prime of x, 5x raised to power 4 plus e to the power 2x minus 4. Now we will find f of x, not prime, f of x, only f of x, by integrating the above. We get, see, if we integrate f prime of x, we will get f of x. So it'll be 5x raised to 5 by 5 plus e raised to 2x divided by 2 minus 4x plus c. It's going to get bigger, but since they are all power rules, they're pretty simple. Now then, here let us cancel and simplify how much we can. It'll be x power 5 plus half e raised to 2x minus, that's 4x itself, plus c. What is the condition given? It is 2 equals to, over here whenever x is 0. So the first one will be 0 plus half. Now what is e raised to 2 to the power 0? It's going to be e raised to power 0, that's 1. So I'll just write half multiplied by 1 minus 0 plus c. 0, 0 is gone. Half to the other side will be 2 minus half equals c. What is 2 minus half? It's 1.5. But generally, we won't have 1.5 in the options. It'll be 3 by 2, because 3 by 2 is 1.5. Or you can just put 1.5 in the calculator. It'll give you the fraction form. That is 3 by 2. So here we go. We have to write this. Okay, I forgot to write. F of x will be equal to x raised to 5 plus half e raised to 2x minus 4x plus 3 by 2. So that should be the final answer, as you can see here. That's it. And over here, that was the first derivative. Integration first time, second time integration. Now this question is not like the similar one, the previous one. Here you can see there is no f derivative of 0. Last time we had f derivative of 0 is equal to something and only f. So we could solve both the constant of integrations. But here if you look carefully, there are only f and f of 3 and f of 0. So how can we solve this? Let's first derive it 2 times. When we derive this first, it becomes f prime of t. It's not of x now, it's of t. So here you will have 2 times t, because t is the variable, plus 2t squared divided by 2 plus c. But I'm going to write c1 because we will do second time integration and then we will have c2. So the answer over here would be 2t plus this 2 and 2 cancels, t power 2 plus c1. That is f prime of t, but I don't know the constant of integration. Let me integrate it again. F of t now. Here it's going to be 2t power 2 by 2 is equal to t power 3 by 3. So it's not is equal, it's plus c1 times t. Now c is c1 over here can be anything, can be 2 or 1 or 5, or it can be 0 as well, but we do not know. So imagine if it was say 3, it would be 3 times t, right, if there's nothing. So that's why I'm just going to write t plus now the second constant of integration. Why? Because we have integrated twice. This was the first constant of integration, now the second one. Now then let me simplify this. F of t is equal to t power 2 plus t power 3 by 3 plus C1t plus C2. Now, whenever we have 0, can you see this f of 0? All the t gets cancelled off, and you can easily find the constant of integration of C2. So what I'm going to do is I'm going to put this first. 2 equals, all these are going to be 0 plus 0 plus 0 plus C2. So what is C2? 2 is equal to C2. Here then, f of t can be written as t power 2 plus t power 3 by 3 plus C1 times t plus 2. But still it's not all done. Why? Because I still don't have the C1 right over here. Now I will substitute the next given condition. This condition says x is 3, or the t value over here is all 3, and the total final value will be 2. So it's 2 is equal to 3 power square plus 3 cube by 3 plus C1 times 3 plus 2. So you need to put all this in the, you can put it directly in the calculator and get the answer, or you can solve it manually. So here 2 and 2 cancels off when it goes to the other side, and then you have 0 into 9, and over here 3 cancels, so you have squared again plus 9, and over here C1 times 3. 18 to the other side is minus 18 is equal to C1 times 3, and over here when you cancel it, minus 6 is equal to C1. I'm so sorry, it's not C1, it's C2, isn't it? Yeah, it's C1, sorry. Yeah, I got confused. C2 was already found out, and C1 is minus 6. So it is t squared plus t to the power 3 by 3 plus okay, this plus will become minus because it's minus 6 t plus 2. So this is the accurate answer. Now here I'll show you in the calculator how we can solve this directly. Here we can just type it out entirely. 2 equals 3 squared plus 3 cubed, 3 to the power 3, and over here use the fraction symbol, divided by 3, plus this is unknown variable x, that's C1, multiplied by 3 plus 2. Press shift and solve, and then press equal to, your answer is minus 6. So that is how we solve it up. The final answer you can see. Now they have written over here t to the power 3 first. That's absolutely fine, you know. You can write this is also correct, this is also correct. And that's it. That's the answer. So similarly, please do try the other problems. I'll do these quickly. First derivative would be 4 times t plus 6t squared by 2 plus C1. Here it's going to be 4t plus 3t power 2 plus C1. I can't use any of these conditions to find the C1, so I directly do the second time integration. So it'll be f of t, that is 4t power 2 by 2 plus 3 t power 3 by 3 plus C1 times t plus C2. When we simplify, it's going to be 2t squared plus t to the power 3 plus C1t plus C2. Here, none of them are 0, isn't it? So which one would you use? Let us start solving with one of it. Okay. So here, this is a little complicated. F of t, right? Here we do not have any 0. If it was 0, we could easily find C2 and then we can find C1. But now which one do we do? What do we do? Among 1 and minus 1, 1 is relatively easier. So what we'll do is we'll put 1. So what happens here is t will become 1 and you will have C1 and C2 together. You can add them up. So let's substitute. 3 will be equal to whatever this f of t is 3, right? What is the t values? It'll be 1 now. It'll be 2 times 1 power 2 plus 1 power 3 plus C1 times 1 plus C2. Here it is 3 equals 2 plus 1 plus C1 plus C2. Now 2 plus 1 is 3. When it goes to the other side, it's going to be 0. That is equal to C1 plus C2. Okay, C1 and C2, when we add up, it's 0. So now let's put the second condition over here. That's going to be minus 2. That will be equal to 2 times minus 1 the whole squared plus minus 1 the whole cubed plus C1 times minus 1 plus C2. Now let's try simplifying this. Minus 2 equals, now minus 1 squared, this will be positive 1, so it's going to be 2 itself, but this is power 3, so it's minus 1. Minus 1 to the power 3 will be minus. If it's odd number here, it'll be negative sign remains. If it's even number, it'll be positive. Minus C1, because minus C1 times minus 1 is minus C1 plus C2. Now let's simplify how much we can. This 2 to the other side, the 1 to the other side. Over here, you can just solve it. 2 minus 1 is 1. It'll be minus 3 is equal to minus C1 plus C2, right? Now we have to use these two equations and solve. What does that mean? Here, you can, what I'll do is you can just choose any one term to take to the other side. If I take C1 to the other side, what's it gonna be? C2 will be equal to minus C1, right? Or you can take the other way around. C1 to the other side will be C1 is equal to minus C2. Up to you. Minus 3 will be equal to minus C1. Now what is C2? Again, it will be minus C1 because C2 is minus C1. So now we can simplify here. I'll just write it out over here. Minus 3 is equal to minus 2C1. Take minus 2 to the other side, it will be minus 3 by minus 2 is equal to C1, or C1 is equal to 3 by 2. That is the first value for C1. Then what is C2? See, over here we have already this condition. C2 is equal to negative C1, right? So C2 will be minus of C1 is 3 by 2. That is C2 is equal to minus 3 by 2. So these are the two conditions. So the final answer f of t would be equal to 2t to the power 2 plus t to the power 3 plus C1 is 3 by 2t. Now it's going to be minus C2 is minus 3 divided by 2. So that must be the answer. Here we go. As you can see, it's positive and the last one is negative. And remember, if you do it correctly, it'll be exactly the first one. C1 will be positive, next one will be negative. So that's the conditions. Now here we have just again double derivative. So we have to integrate it twice to get the function f of x, isn't it? So that's it. Let me solve this out quickly. 3. What about the sign over here when we integrate it? It'll be minus cosine x plus 4x power 3 by 3. And then now this is not the answer, plus c. And again, now over here the conditions are not given. Let's just integrate it again. That's it. So here it'll be minus 3. Okay, I'm writing it again. Now we will integrate it again. This first time is done. Let me integrate it again. It's gonna be 3 minus cosine is just sine x plus 4 x power 4 by 3 times 4 plus c1 x plus c2. Now then we have minus 3 sine x, this 4 cancels, plus x power 4 by 3 plus c1 x plus c2. There are no conditions, so that must be the answer. Yes, that's it. I was wondering, satisfying the conditions, and there are no conditions mentioned. So this is it. Now the next one as well. Over here, what's going to happen? First time when you derive it, it's going to be x 3 by 2 by 3 by 2. Because x power half, when you increase it, you're integrating it. So add it by 1. So that's the answer. And over here, when you derive cosine, it's just sine, positive sign. Plus c1. And now this must be added up again. See, now I'm going to rearrange and write this because fractions are going to be a little messier otherwise. It'll be 2x 3 by 2 by 3 minus 2 sine x plus c. Now here we have 2 by 3 x. Now add one more. It's going to be 5 by 2, isn't it? It's 1.5 plus 1 plus 1 is 2.5. It's 5 by 2 by 5 by 2. Minus 2 sine, okay, not sine, it's minus cosine x plus, this is c1 x plus c2.
Now then, this, let's rearrange and write these. So here, this denominator remains with this, and this goes up. So it'll be 2 times 2, it's 4. I'll write it one by one. 2 by 3 multiplied by 2 by 5, x 5 by 2, minus and minus becomes plus 2 cosine x, plus c1x plus c2, and this is 4 by 15 x 2.5 5 by 2 plus 2 cosine x plus c1x plus c2. That must be the answer. I've cramped it up over there. You can see this is it. So it's 4 by 15 x 5 by 2 plus, because minus and minus becomes plus over here, and that's the answer. Here now we have got triple derivative. So we have to integrate it 3 times. Just keeps on going and going and going. So it's not that difficult. If you know the rules, it's very simple, isn't it? So this is x minus 3. Okay, this is the question. We will have this as the question. We'll integrate this now. It's gonna be 4x minus x raised to minus 2, because we add 1, isn't it? Minus 2 by minus 2 plus c1. Again, we have 4x power 2 by 2. This minus 2 cancels, so it'll be just plus x. No, let me write it over here. X minus 1 divided by minus 2 times minus 1. Why? Because whatever is the answer, I write it down. And over here it's x plus c2. Okay, let me simplify this before going the next step. I've integrated thrice. 2 times is done. It's 2x squared. This minus remains because this cancels off and 2 is gone. It'll be x power minus 1 plus c1x plus c2. You can just put this all in calculator. You'll get minus 1 here. Because 2 cancels. Minus minus cancels. This minus remains, and that's it. Now let's integrate it once again. It's going to be 2x power 3 by 3 minus. Now what is 1 by x raised to minus 1? Don't think it's 0, because divided by 0 is not possible, right? It's natural logarithm x, isn't it? This is the rule. Remember, integration of x power minus 1 is ln x plus c dx. So that's the thing. Basically, x raised to minus 1 is 1 by x, and derivation of ln x, natural logarithm x, is 1 by x. So it's the inverse of those, right? And then over here we have x squared by 2 plus c2x plus c3. So this is the final answer. What about over here? So this one, it'll be minus cosine x. This is the first time. Okay, f double derivative of x will be minus cosine x minus e to the power x plus c1. First derivative would be, I'm integrated once, second time antiderivative now. It'll be minus sine x minus e to the power x plus c1x plus c2. Now lastly, the function f of x will be given by the final integration. It will be minus cosine, minus and minus will be plus, or let me do the step here. Minus and minus, minus e to the power x plus c1x squared by 2 plus c2x plus c3. Now the final answer would be cosine x, because minus and minus will be plus e to the power x c1x squared by 2 plus c2x plus c3. That is the answer. So here we go, the answers. Minus line, this is ln or natural logarithm, you can call it anything. And here we go. This one was pretty easy. Why? Because it was just e to the power x. It remains the same, right? It doesn't matter. And left side, it's sine, cosine. Only the signs needs to be remembered. So over here, this is it. And then over here, these are the constants. Now, finally, the last 3 problems. Determine the position function if the velocity function is v of t, that's given over here, and the initial position is s. Now, in the term 1, if you remember the derivatives, we had position s of t
We derived this. S derivative of t would be velocity function, right? And if you had derived velocity, that was the acceleration function. Now, what do we have? We have velocity. We need to integrate it and get back to the position. That's it. So, integration of velocity would be equal to the position, because derivation of the position is the velocity. So let's integrate this. Basically, we are dealing with antiderivatives, integrals, or integration, right? So we have most of the functions which are given, we need to just integrate them. So 3 minus 12. Now here you can use the calculator. Why? Because it's only single derivative. If it's more than one, single time integration. If you're anti-deriving it more than once, you cannot use calculator. Here you can, but since we know how to solve it, I'll just use the rules. Here we need to integrate this with respect to time dt. So it'll be 3t minus 12t power 2 by 2 plus c. And here we go, it'll be 3t minus 6t squared plus c. Now here we have the initial position of 3, that is equal to 3 times 0. This s of t will be equal to, wherever t is there, you put 0 minus 6 times 0 squared plus c. So the value of c is 3. So the final answer, the initial position function s of t is given as 3t minus 6t squared plus 0. Or in your options, it can also be minus 6t squared plus 3t plus 0. Or you don't need to write 0 altogether, it will be only so much. Okay, oh sorry, it's not 0, it's 3. What am I writing over here? It is 3 in both. The c value, the initial, the constant of integration is 3. What about the next one? Same thing, but here it's e to the power minus t. It's not just t. Now the sign will be there, okay? The minus sign will be there. So when we integrate it first time, it'll be s of t. That's going to be minus 3 e to the power minus t. Why? Because when we integrate e to the power minus t, the minus sign comes out, right? Minus 2t plus c. Now substitute 0 over here and over here. So it's going to be 0 equals minus 3 e to the power 0. Minus 0 is 0 itself. And we have minus 2 times 0 plus c. Now what happens here? This is 1. So we have minus 3 plus 0 plus c is equal to 0. This to the other side will be 3 is equal to c. Even over here, the constant of integration is 3 itself. So here we have to write minus 3 e to the power t. Sorry, it's minus t minus 2 times t plus 3. This is the answer. So that's how we solve it. The first one was, okay, it was written like this, 3t minus 6t squared plus 3. And the second one over here, we have minus 3 e to the power minus t minus 2t plus 3. And now the final problem, here we have to double derive, integrate, antiderive. So why? Because acceleration is given. When we integrate acceleration, let's do it over here. 3 minus cosine t plus 1, that is 1 becomes t plus c1. What happens here? We get velocity, and they have given the velocity value. So over here, let me rewrite it. Minus 3 cosine t plus c1. This 0 is equal to minus 3 cosine times 0 plus 0 plus c1. And then here all you need to do is solve it. Minus cosine 0 is 1, right? So it'll be minus 3 plus c1. So 3 is equal to c1, the first constant of integration. Let's write it out over here. Minus 3 cos t plus 3. This is the velocity function. Now to find the position function, you need to just integrate this again. It'll be minus 3 sine t plus t squared by 2 plus 3t plus c. And now this is actually c2, but since we are already put the constant of integration, we can take them as c and c itself. Now here what we do is we use the second condition. So 4 will be equal to minus 3 times sine 0 plus 0 squared by 2 plus 3 times 0 plus C2. So this 0 is 0, 0, over here also 0, we get 4 is equal to C2. So the answer over here would be, for the position function, minus 3 sine, over here, t plus t squared by 2 plus 3 times t plus 4. So that's the final answer. From the acceleration, we can get position function. There's no calculator method for double integrations, so you have to do it manually using rules. So here we go, it is minus sine t, and this is, now over here I realize they have not considered this 1. If you have this 1, it'll be t, isn't it? So they have not considered it. That's the reason why the answer is different, but this is the accurate answer which I've written over here. All the solution sets are not exactly accurate at times. So here the velocity function, what happens is, this is correct, minus 3 cosine t plus t. Why? Because what is the antiderivative of 1? It'll be t, isn't it? Plus c1. The 1 is missing, therefore they miss this term entirely, the t square. This, when you integrate it, t squared by 2 is missing here. Okay, I thought that was the last problem. There's one more problem. Let's quickly solve it. It's the same like the previous one. Here, let's find the velocity function. It will be t to the power 3 by 3 plus t plus c1. And here, the velocity function is given. The condition for the velocity, initial velocity, is 4 equals 0 by 3 plus 0 plus c1. So c1 will be 4. So velocity function is t to the power 3 by 3 plus t plus 4. Now what about the position? Acceleration is already given. Position function, you just integrate it again. It'll be 4 x power t to the power 4. 3 times 4 will be 12. I'm directly writing it over here, and it's t power 2 by 2 plus 4. It's 4. That's over here, 4t plus c2. And now let's solve this one. It's 0 is equal to 0 plus 0 plus 0 plus c2. So c2 is equal to 0. Why? Because x and y both are 0. So this is all cancelled. Only c2 remains, and that's equal to 0. So the position function would be t to the power 4 by 12 plus t squared by 2 plus 4t only, because that's plus 0. We don't need to write that. So here we go. That'll be the answer. And over here it's accurate because they have considered this 1 and they have written this t here, so everything will be all right. So that's the final answer. The 11th question is to compute the summation. It is from the lesson 5.2. Here, all these problems can be directly solved in calculator. All we have to do is use this summation notation. You can see over here, if you press shift and this log symbol, you get that. And this I variable can be written in terms of x, alpha and x, because over here they have clearly mentioned it's x is equal to. Whatever is the variable, you just take it as x minus 1, and then it starts from 1 and it goes until 70. And here we go. Just in a few seconds, you'll get the answer. It's 7,385. Now, sometimes it might take up till 30 seconds, some of the complicated problems, but you'll definitely get the answer. Here it is 3x minus 4. And you can see the lower limit is 1 and the upper limit is 45. All you do is press equal to and you will get the answer, 2,925. Similarly, you can solve all these problems. I'll do the 12th one here. It is 8 minus I, that is alpha x. Over here the variable is only x. It starts from 1 and it goes until 50. So this is the answer here. Minus 875. Let me do this as well because there's square involved here. So it is 4 minus square of I, that is x squared, from 1 to 40. And here we go, it is 21,980. Yes, that's the correct answer. Similarly, you can solve these. Doesn't matter they're huge, it's the same method. Let me try this one here. It is n, but we use again here x squared minus 3 times x plus 2. And it's from 1 till 100.
And here we go. The answer will be, just take some time, 3,223. Oh, sorry, 323,400. That's how we solve it. Similarly, you can solve these over here. Just make sure you put the proper brackets. Now here you can see it is, let me clear it off. Shift summation. This is sigma interval, and open the bracket. The already one brackets are there. Those big brackets are already there. Just open one bracket, write x minus 3, close the bracket and square it. Over here, you just close the bracket and square it up. And then you add x and subtract 3. It starts from 3, it goes until 30. The value is 7,308, and you can see that's the answer. Similarly, you can solve all these problems. Here it starts from 4 to 20. Just type it out and you'll get the answer. Now, what about this problem? Here it's n, isn't it? Here you don't need to solve it by writing. All you need to do is type it out. So all the four options need to be available. Let's press shift and this symbol, you get the summation. Now it's k, but we use x squared minus 3, and the limit starts from 3 until n. Now what is n? I will just take a value of 10. Okay, what is the answer? It's 356, right? Now here, look, this is the answer. It is n minus and so on. All I have to do is I have to just choose the same n value here, and I must match 356. So whatever I get over here, 356, write it down. Now try all the four options. I'll try this one. It is x times x plus 1, close the bracket, open the bracket again, 2x plus 1 here, divided by 6. And then what do we got? What do we have? It's 3 times x plus 1. Calculate, what did I take? N as 10. It is 356. And now let's calculate it, say at 50. You do not need to take big values. You can take smaller values. It's 42276. Or let me calculate it at 3 itself. It'll be 6. Now let's do this over here. But what you need to do is take always more than this. Okay, it's always more than this. But this is going to work. 3 is going to work. But from 3 you need to take. But 3 and 3 will be the exact same value. It's better to take more than 3. 10, 20 or 15. What I would personally take is, if it's 3, I'll just take 5. The next easy whole number to remember, it's 5. Okay. Now let me solve this. Shift dy by dx. It's x squared minus 3, and it starts from 3 until which is the ending number. If I take 5, it should be 41, and if I take 3 here, it should be 6, and I had taken even 50, but I forgot what was the number, but it will be the same thing. It was 42,000 something. Yes, that's how we solve it. Now there is no problem over here with infinity. This is the last problem. But what if you had infinity here? Then you just take a huge number. Don't take 999 because it'll just be a math error. It can't compute so much. Take a big number and it will try to, round off to one number. But these are not possible because these are specific. The infinity problem will be a specific problem. As you increase the number to a big number, you will get a specific number. Sums up to become certain number, maybe 103, and it won't go more than that. So that is the thing. If it was infinity, just take a big number here, and usually if you just say 90 or 100, it'll be almost the same value, and then you can easily check the option and select the correct answer. Over here, this is not a particular problem for infinity. There are specific problems, but here it's not mentioned any problems for infinity. But let me just solve this out. Here we have 0, and then we have here plus 5. See, I'll choose 100 for now, and let me see the answer. It just takes too much time to compute. It's such a huge number, right? But why do we do this? There is no need of this. I will just choose a simpler number. I'll choose, say, 5. Now let's look into the options. Here, what have we got? We have got this has one of this is the correct answer, but you'll have four options. You need to try it in all the four options, only then it'll work. So let me try x times x plus 1, close the bracket, open the bracket again, 2x plus 1 divided by 6, and over here it'll be plus 5 n. So calculated at 5, here we go, it was 85, and calculated at say 100, which we did, it was a huge number. This is the answer. So this is using the formula, but we do not need to use the formula. We can directly use the calculator and solve it. The question 12 is to estimate area under a curve. It is from the lesson 5.3. All these questions can be easily solved in the calculator. Now here there are a few important things to remember. The left endpoint, midpoint, and right endpoint methods are used to evaluate the area. Now what does this mean? I will solve all of them in the calculator, but before that, left endpoint means, imagine this is the curve. We start from the left endpoint, from here, whichever left point, this point, and this, and so on. So many number of rectangles are used from the left side. Whereas the right endpoint means we are going to use the right side one, two, three, and it goes on. Midpoint will be from the center, and that's the most accurate method. Now, when we do it in the calculator, we just get one exact value, which is n equals infinity. And that's very, very close to the midpoint. The left end point either will be lesser than that or more than that. It's not always this will be less or more. It depends on the curve. If the curve is increasing, this left end point will be low, whereas the right end point will be a overestimation, and this will be underestimation. Whereas if it's decreasing curve, say its curve is something like this, then the left endpoint will be more and right endpoint will be less. That's a basic thing of this. And now let's look into the method to solve it in the calculator. Here you need to use the integral symbol. It's about integration, and the limits are also given. Let's put in x squared plus 1. And over here, the limit is from 0 to 1. The lower limit is always down, and the greater or the higher limit is always up, the bigger number. Now, this n is ignored because we're using the calculator method, and the answer is 4 by 3 or 1.333. Now, if you see the answers for the left endpoint, since it's x squared, it's a parabola. Now, how does x squared look? Let me just draw the graph here. X squared is something like this. And since we have 1, 0 to 1, from year to year, 0 to 1, it's increasing. The curve is increasing, isn't it? So this will be lower estimate, and the right endpoint will be the higher estimate. So here we can see the answer is lower than 1.33, whereas the midpoint will be most accurate one, 1.33, and this right estimate will be greater than 1.33. Now, how would you understand which is most accurate? In the options, you can just see which is very close to it. If it's the left endpoint they're asking, since it's increasing, you should go to anything that's closer to this. And also, all the options won't be the exact same. They might ask you only the midpoint, and there'll be only one option to choose from, so you can easily get the accurate one, or just here and there. If there is exponential functions, then these values vary a lot. We will look into that in a minute. Let's do one more problem. It's the same thing, but what do we have is from 0 to 2. Now here, you can see it's 4.66, and here we have 4.66, whereas this one is underestimated. That's the left endpoints, whereas the right endpoints, as you can see, is overestimated. And then what about this problem again? Integral symbol, square root x plus 2. And here we have 1 to 4, and this is an increasing function, so it'll be underestimation for the left endpoints, and yes, it is underestimation. It's almost accurate for the midpoint, whereas it is an overestimation over here for the right endpoint. Similarly, we can solve the other problems, but now here you can see it's exponential. What happens is it's e minus. So here the function will be decreasing. So this left endpoint will be overestimated and right endpoint will be underestimated. Let's look at it. All we have to do is integral. E is shift and E over here minus 2x. And the limits are from minus 1. So here go down to the limit. Minus 1, that's the lower limit. And above is higher limit is 1. And the answer is 3.62. You can see here it is almost accurate, but here it's 4 and this one is 3.1. Why is this? Because exponential functions changes rapidly, isn't it? So here the variation is too much because they are exponential functions, whereas the other functions, they don't vary too much. Exponentials dip down quickly or rise quickly. Exponentially they change. That's the reason. Now, cosine functions, please remember to get into terms of radians. This is in degree, shift, mode, and 4. Now it's in radian. R is for radian here. Now, what we do is integral cosine x, close the bracket, and over here we have 0 until the limit of pi by 2. Pi is by shift and into 10th power symbol. You get pi divided by 2, and the answer is 1. You can see it's overestimated because over here then again it's a decreasing function. It's cosine, right? From 0 it decreases to pi by 2, so that's why it's overestimated. Here it is almost accurate, 1.004, and it is underestimated here. Last problem, let's do the same method. X cubed minus 1, and over here we will have negative 1 to positive 1, and the answer is negative 2. Now since this is a cubic function, what happens here? Something like this, right? At minus 1 to 1, this is decreasing, so therefore this will be an overestimate, whereas the right endpoint will be an underestimate. It's dipping down towards the right, so it will be the right side that's lower estimated. That's the reason. Also, you can use the formulas and solve it up. If you don't want the formulas, you can directly put them in the calculator and try to figure out the answer. So it depends on which is asked, and depending on the function, you can predict the midpoint very easily. If it's left endpoint, if it's a decreasing function, it will be overestimated, whereas then right endpoint will be underestimated. Whereas if it's increasing function, which I told at the beginning, if it's increasing, left endpoint, see left side, it's low estimated or underestimated. Right side will be overestimated there. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. 13th question is to learn the properties of definite integrals. It is from lesson 5.4. Here we have piecewise equations, and they have told us to compute the integral from the limit 0 to 4 f of x dx. But the function f of x is split into two. All the values x less than 1 is 2x, and all the values greater than 1 is 4. It can be directly solved in calculator as well, but before that, what does these piecewise equation mean? Piecewise means the domain of x varies for both these terms. For the function f of x, it's two different domains based on the x values. So here we have 0 to 4, right? F of x. But we can't have this integral. We have to split it up from 0 to, over here it's 1. From 0 to 1, it's less than, x is less than, it will be, f of x will be 2x dx plus from 1 to, what is the upper limit? 4. It is 4 dx. This is it. You put this in the calculator, you get the answer. Or you can directly solve this as well, integrate it. It'll be 2x squared by 2 with its 2, and the limits are 0 to 1, and plus it'll be 4x. The limits will be from 1 to 4. Over here it's just x squared. The limit is 0 to 1. Let's apply the limits over here. It'll be 4 times 4 minus 4 times 1. And over here, what happens? It'll be 1 minus 0. It's 1 itself. 1 plus 16 minus 4. That is going to be 13. That will be the final answer. But instead of doing all this, you can directly use your calculator and solve this. Here, all you need to do is see the question. It's integral. Before writing f of x, the limit is from 0 until whatever the x domain is given over here, it's until 1. So 0 to 1, 1 less than it's 2x, right? So I'll write over here 2x, 2 and x. So add this over here, go next and write plus, again integral. Now what is the remaining one? You can easily write 4. The limit will be from 1, it's greater than 1, right? Which is the maximum limit given? It's 4. So the answer must be 13. This is how we solve it up over here, just by splitting the intervals. Since it's in the electronic part, you do not need to write anything directly. You just put this in the calculator and here you go. What about the next one? Again, it's just the same. Let me do it over here. You need to have 2 times. Now, first one, here it's less than. It's 2, only 2. And we write the limit from 0 to 2 because the domain is cut at 2 plus integral 3x from 2 to 4. And here we go. The answer is 22. That should be the final answer. You don't need to split it out and do all the stuffs. Directly in the calculator, you can just compute it. It'll be split into 2 terms. You can directly solve it up. The question 14 is about integral mean value theorem. It is from lesson 5.5. Here we can solve all the problems in the calculator, but only thing is you must remember a little bit of the formula. See, whenever these limits are given, you have to do, for the average mean value theorem, you're finding the average, right, of this given interval. So we have this formula 1 divided by the higher limit, the upper limit, 3 minus the lower limit. Here it'll be 1 divided by 1 minus 0. And then we do the integral x squared minus 1 with the limits 1 to 3. Over here also it will be 0 to 1, 2x minus 2x squared. Since it's in the electronic part, we can directly use the calculator. Let's take our Since it's in the electronic part, we can easily use our calculators and solve. Here, let's do the first problem. All you need to do is add this extra part, 1 divided by 3 minus 1. That's going to be half, 1 by 2. Integral x squared minus 1. And the limit is from 1 to 3. That'll be the answer. It's 10 by 3. So here, that's the answer. But if you had removed this, if you had not put this, then the answer will be wrong. It's 20 by 3. See, it's wrong. So make sure for the average mean value theorem, you add this part. Then everything else in the calculator, only this extra part, please remember it. So even over here, it'll be 1 divided by 1 minus 0. See, in this case, it's 1 itself, right? 1 by 1 is 1. So it doesn't make a difference, but any other limits, it'll make a difference, right? So please make sure you write it properly. 2x minus 2x squared. The limit is from 0 to 1. The answer is 1/3. What about the other problems? We can do the same thing here. First thing is, now since it's in trigonometric function, shift mode and 4 radians. Whenever you see trig functions, you can leave it in radian mode itself because even these other problems can be solved in the radian mode and you'll get the correct answer itself. It's 1 by pi by 2 is given over here. Pi, shift and the symbol here at the bottom, by 2 minus 0 here. Upper limit minus the lower limit. Now integral cosine x, close the bracket. The lower limit is 0, but the upper limit is pi by 2. Use the fraction symbol, pi divided by 2, and the answer is 0.36. Okay, now it's 2 by pi. What happens is you will not have this option. This 0.6366 won't be there in your options. This will be there, 2 by pi. You can either do like this. Answer, no, it doesn't show. You can't press SD. So the only way is you need to remember this, write it down somewhere, 0.6366, and start solving all the options. It might be one option might be 1 by pi. You can see this is not the correct answer. Then let's try 2 by pi. Whichever is the options, you need to try 1 by 1. And you can see over here it's 0.6366, which matches with the this integral. So that's the correct answer. What about the last problem here? Same thing. I've directly written this, but we have to write the formula behind it. That's 1 divided by 2 minus 0. So here it's alpha x, and we have 0 to 2. Remember here, I need to multiply it with 1 divided by 2 minus 0, or 1 by 2. That's half. The answer is 3.19 even over here. So this is the correct answer. It's 3.19 for us. Whereas even if you put answer SD, it won't show us the exact one. Why? Because it's in decimal here. But the final answer in the options will be something like this in fractions. Let's put this out over here. It's 1 by 2 multiplied with. You can avoid the multiplication symbol, but make sure you write the brackets. Otherwise, it'll be wrong. It's shift e to the power 2 minus 1 and close the bracket. Now, in case you had not put the brackets, it's entirely wrong, because over here it'll be half times e squared minus 1. That'll be separately done. So here it's 3.1, and yes, that's the correct answer, isn't it? So this is how we can easily solve all these problems in the calculator itself. Finally, we are at the end of the electronic part. It's the question 15 to use substitution to compute the integrals. It's from lesson 5.6. Here, since it's the electronic part, we can solve everything, all these problems in the calculator itself, provided we should know all the four options. Otherwise, we cannot use the electronic method. Now, let's take our calculators and see how we can solve it. First thing is, whenever you have integrals, don't put this integral symbol, just put the values. What is the question? It's x power 3, the given question. Then we have square root x power 4, x raised to 4 plus 3. And here, just calculate at any particular x value. Don't use any negative numbers. Don't use 1. Don't use 0. Any other numbers. You can choose 1.5, 1.9, 2, 3, 4, 100 as well. I generally go with x2. You can just remember this value. X times 2. Don't leave it in terms of fraction or radical form. Make sure it's in decimal. It's 34.87. You can write it somewhere. And then you need to look into all the four options. Now, this is the correct option with plus C, right? Now, one of the correct option, when you derive it, at x is equal to 0, when you derive, shift and d, the symbol gives you d by dx, right? At x is equal to 2, will give you the same answer, 34.87. Let's look at this. Shift d by dx, that's deriving. The answers 1 by 6. Here it's alpha x to the power 4 plus 3, close the bracket, raised to the power 3 by 2. And here we have x at 2, because we assume the x value of 2 right at the beginning. So here we go, it's 34.87, absolutely right. Same thing can be done over here. Use this integral 1 plus 10 x as 2, calculated at 2. It's 4.58. Now I will derive this 1 by 15 times 1 plus 10x, close the bracket, raised to the power 3 by 2 at x is equal to 2. We just go out and put x is equal to 2, must be 4.58. So that's it. Anytime. Now let me just change it over here. Let me change it to 3, 5.56, right? Now look at this. 1 plus 10x calculated at 3, it should be 5.567. It will match. You can solve all these problems, it'll be the same thing. Let me do these trigonometric functions as well. Please change the mode from degree to radian, because it's trig functions. Shift, mode, and forward. Now it's in radians. Now let's type it out. Only these questions first. Sine x, close the bracket, divided by square root cos x. Why do we do the question first? Because we have a definite question, but the options, there are 4. We don't know which is correct one. It might be A, B, C, D. So try each one option. First try A. If it's not matching, then go to second option, third option. You might get in the second option the correct one. You don't need to do the third and fourth. That's why we do the question first and try to match the options with the question. Here, calculated at 2. Okay, now here we got a math error. Why? Because there's square root and the domain over here, you might get a negative number. So in such cases, whenever you get math error, try to change the x value. Okay, let me try. 3 also will be a math error. Why? Because the domain is not, it's beyond, you will get an error. So how about 1? But I've told you not to take 1, so let us take 0.5. It should work with 0.5. Here we got 0.511. There are rare cases where you get a math error. Whenever you get math error, just choose a value other than, usually, right? Whenever you get math error, you can take 0.5. Even there's another question where we did the same method and we got the same error with inverse, sine inverse problem, I guess. We took 0.5 and it worked out fine. So if you come across this problem, just take 0.5 and we have 0.51177 and it's in radian mode. Now try to derive the answer, that is minus 2 square root cosine x. You don't need to put plus c because when you derive any constant, it will be 0. Now, if you put 2, it will be error. No. Why? Because we had changed the value to 0.5 and it was 0.1177. Absolutely right. So this is how we can solve it. How about this one? It's the same thing here. Now sine x, close the bracket and raise it to the power 3. This is not the x, this is the entire thing raised. Or you can put the brackets here just to be on the safe side. Bracket for sine. So here the double bracket is because x also has a bracket and then this is also having a bracket. Multiplied with cos x. Okay, calculated at 2. It's minus 0.3128. Now let's solve this up over here. It's not solving up, sorry. Remember this, negative 0.31. It's shift d by dx. Why? Because we have to derive this sine. Before that, I have to put the fraction symbol. Sine, I'll open the bracket, put the sine value x, close the bracket 2 times because this is for the x, and now I closed it, which I opened initially, raised to the power 4 divided by 4 at x value of 2. It should be negative 0.312. That's it. Please do try these problems. T here is just a variable, put it as x alpha x and you will get the answers. Let's see these ones. Now I will do the 11th one here. It will be, okay, these are the answers. Let us put in the question first. Alpha x. You can put multiplied or you can directly write e to the power, it's fine. Raised to the power again x squared plus 1. Calculated at 2. The answer is 296.82. Now let me derive this half, that is 0.5, or you can write fraction half. E to the power x squared plus 1. And we have over here at 2. It's same thing. Similarly, you can try this. It's the same concept repeated. You can try this and derive that at the same point, and then you will get the same correct answer. And what about these? This is similar. Okay, let me do both of these. Over here are the answers. You can see this first one is plus c. That's not required. Only this part is required for us. So given question, that is shift e to the power square root x divided by square root x, calculated at 2. And we are getting answer 2.9. That means shift d by dx over here, 2e raised to the power root x, that's square root x, at x is equal to 2, must be the same answer, 2.9. What about this one? Cosine 1 divided by x, close the bracket, divided by x squared. Here calculated at 2, the answer is 0.219. Now put this answer chef d by dx minus sine 1 by x and close the bracket. You don't need to put any c because it'll be dissolved to 0 when you derive it, but the x value must be 2 itself at 0.219. It's the same answer. So this is how we can solve any of these problems and you will get the same answer. Let me do natural logarithm as well. So we have first fraction, square root. The only issue in the exam is you need to make sure you do it for all the four options and check. If you get the answer in the first or second, then it's fine. Otherwise, you have to go until you get the answer which matches the question x value. So here x calculated at 2, the answer is 0.416. Now let us look at the answers. Here we go. It is chef d by dx 2/3 of, open the bracket, natural logarithm x, close the bracket and raise it to the power 3 by 2. It's not 2 by 3, it's 3 by 2. X value is 2. The answer is 0.416. Now, if you want, you can change this. Let me change this to 3 or anything, 1.5 for that matter. It's 0.4245. Look here. It will be the same over here. ln x, close the bracket, x. Calculated at the same value, I took 1.5, it should be 0.4245. For this last problem, the solution set is having an error. Let me solve this out over here and then let's use the answer, proper answer. It's all correct, only the square root is the error over there. So how we solve it is, if you're doing the substitution, we have to consider whatever is inside the square root. There are a few thumb rules. Over here, I can just understand whatever is inside square root. I can easily consider to be u, that is tan x. And then what's going to be du? Du is going to be secant squared x. Now, as du by dx, sorry, with respect to x we are deriving. Now we need dx, not du, because over here, this is u. What is dx? Dx will be equal to, this secant square x goes to the other side, dx comes up, it'll be du by secant squared x. We can just substitute in the given question. So the integral will be secant squared x square root u, dx is du by secant squared x. This and this cancels out and you're only remaining with square root u du. Now let's integrate this. This is square root, that's power half, isn't it? So integral of u to the power half du. What's going to happen? That will be equal to u3 by 2 divided by 3 by 2 plus c. Now here when we write this in fractions, we can't write divided by, we write it as, we swap them up and write it as multiplication. It will be 2 by 3 u3 by 2. Because this in the denominator remains, whereas this one goes up. It's like a divided by b by c. What is the value? It'll be ca divided by b, isn't it? The b remains, whereas this goes up. It'll be ca. So whatever is down over here will be multiplied with the about plus c. Now what was u initially which we assumed? U was only tan x. So 2/3 of tan x 3 by 2 plus c is the correct answer. Now if you look at this solution over here, it's all right, 2 by thirds, 3 by 2 raised to the power. That's also correct, but only the square root tan x is the error. So let's use the correct answer and use the calculator method here. So what I'll do is I'll put this given equation, that is 1 divided by secant square. 1 divided by secant is not there, it's cosine x, close the bracket, and raise this to the power 2, multiply it with square root tan x. Tan x is directly there, alpha x, close the bracket, and calculate it at say 2. Now I'm getting an error, so what should I do? I'll just jump to 0.5 and here we go. The answer is 0.9597. Now let me solve this with shift dy by dx. It's 2/3 of square root, sorry, not square root, open the bracket, tan
x, close the bracket and raise it to the power. I've closed it twice because I've opened it once over here. This one is for x and then for the tan. Raise it to the power 3 by 2 or 1.5. And then here we have to write 0.5, not any other value. Imagine you put 2, it's an error. Why? Because we got error at the question, right? So it'll be 0.5, it should be 9597, and that's the correct answer. So this is how we solve these problems. And this is error. The square root must not be there over here. And that is the end of all the electronic part questions. I hope you have found these videos helpful. And if you can do a huge favor to me, that is by sharing these videos with your friends who also can benefit from it. All the advanced grade videos, EOTs, and lesson explanations are available. Please do share it for those who can benefit. And also, if you could subscribe to my channel or like these videos, it would mean a lot to me. Thank you very much for watching my videos. I wish you all the best for the exam.